Hello, everyone. Thank you so much for joining us for our AWS workshop, Data Intelligence with Databricks on AWS. Before we jump into content, I want to run through a few housekeeping items. So you will see a feature at the bottom of your Zoom screen with the Q&A label. Please pass any questions that you have through this feature. We have disabled the chat to make sure that our support subject matter expert team can answer your questions thoughtfully throughout the entire session. And if we do not get to your questions throughout the session, we will get a list of those post-program, and we'll make sure that we get an answer to you. The session will be recorded, so both the slides and recording will be shared tomorrow. You will see that in your inbox with the same email that you used to register for the program. Without further ado, I am going to pass it to our host, Will, and you will see lab access instructions pasted here, but I will also populate them in the chat for you to copy and paste. And Alex, who's going to be owning the lab process today, will also take much time to walk through that setup process. Will, I will pass it over to you and populate a welcome poll as well. Thank you so much to everyone for joining us today. Will, your audio is not working for some
Can you hear
reason.
me?
Yep, we're all set now. Thank you.
Great. Yeah, thanks, Sophia. Appreciate you all being here today to join us for a deeper dive on Databricks. My name is Will. I lead the AWS partnership here at Databricks, and I'm excited to tee up the conversation that Alex is going to lead by giving you guys just an introduction to Databricks. So I think at this point, it's cliche to say that every company wants to be a data-driven company. I think in the last couple of years, it's also become cliche to say that every company wants to be a data and AI company. And Databricks has really been at the forefront of helping companies achieve this outcome. So this is not aspirational for many of the leading companies in the world today. In fact, many of the companies are achieving that vision of being data and AI companies. And you can see a cross-section of Databricks customers who are leaders in the industry and transforming in this way. You have companies like Biogen that are using data and AI to power new drug discovery. Companies like ABN AMRO are delivering products faster to market. Time to market increases advantages in terms of maximizing revenue and customer share. Customers like Rolls-Royce are using data and AI to improve, to reduce maintenance downtime and improving the overall product and customer experience. And then brands like Burberry are using our products and data and AI to hyper-personalize their interactions with customers, creating more valuable experiences with each contact. That being said, we see patterns across all of the leaders in this space that I just mentioned. And really, it starts with when we talk to CFOs, making the investments required to become data and AI companies. The main thing they're interested in is reducing costs. They've kind of built these massive data estates over the years from many disparate systems, and maintaining multiple disparate systems across all of your data estate increases costs. So one of the main drivers that we're seeing is this pattern of looking for reduced TCO. And the reduction in cost is used to reinvest in the business. So the more that they're able to save costs on the data platform, the more they're able to reinvest in new data projects. Second thing that we see is that you have to trust the data, and you have to trust that the data can be provided securely. And so data quality is a really important thing that we see across customers, them wanting to know the source, the quality of the data all throughout the value stream, as well as ensuring that they understand and control who has access to the data, but also making it as consumable as possible. And then ultimately, all of that is in service of kind of the headline, which is transformational AI, using AI, data and AI as a tool to kind of reconfigure and reimagine the way the business runs, which is what many customers are interested in. That said, it's not difficult. It's not easy to achieve this level of success at scale in an organization. The reason for that is the data state is fragmented. So when you think about, as I said, this kind of sprawl that exists in many companies that have had multiple products, disparate line of businesses, all having their own data strategy. Bringing that all together is very complex, comes with high costs, and you're dealing with all these kind of proprietary formats and data sources that don't all necessarily fit cohesively into one architecture. So this is kind of where Databricks and our value and prop around data intelligence and our platform comes into play. We're really addressing two of the key problem statements in what I just said. One is unifying all of that data from all those disparate systems into one unified Lakehouse architecture, having strong governance across that data to understand where is my data coming from, how is it being transformed, having really granular metadata about what's inside that data, the content of the data, and then being able to securely determine who should have access to it. That's a big part of our value prop. And then all of that ultimately in service of, as I said, the headline around AI. How do you take advantage of that unified data platform, the governance on top of it, and use that to support a number of different use cases across the enterprise where AI is being intelligent based on its understanding of your data to transform the business. So the first problem statement that I talked about is probably the most common pattern that we see with our customers going through kind of a migration and a modernization journey, and that is unifying their data. So generally what we see is we have customers with many different formats of data, structured and unstructured data, and they have potentially multiple copies of this data across different systems that are using it for different use cases. And in some cases, this data is not in open formats that you as the customer control, that prevent you from having lock-in to one vendor that stores the data in one way versus another. And so we really invented and have helped customers adopt this paradigm of the data lakehouse and the lakehouse formats. And we support all of the leading formats that customers building lakehouses are deploying, whether it be Iceberg or Delta. We are the founders and creators of Delta Lake, but we also have the founders of Iceberg working at Databricks, leading engineering and bringing this together. And then we support the most common open file format for the Lakehouse architecture, which is Parquet. So this allows you to bring all of your data, no matter the type of data or source, into one unified Lakehouse architecture. Part of bringing that data in is understanding how to connect from the various sources, data sources that exist out there. Increasingly, business applications that customers are using from leading SaaS vendors are some of the top sources of data that customers are looking to easily connect in. So through our Lakeflow product, one of the core capabilities is the ability to have easy connectors into these various data sources to bring that data into that unified Lakehouse architecture. Once you connect to those data sources, we're helping customers with Lakeflow build declarative pipelines that help you reliably transform that data, make really robust pipelines that you can ensure, as I said at the beginning, the quality and the integrity of the data. And then as you start to operate at scale, you want higher levels of automation for these end-to-end workflows to establish these connections, build these pipelines, and plumb them into the architecture. So we have our jobs component of Lakeflow that adds orchestration and automation and deploys AI to help you optimize these pipelines and these connections to your data sources. At the core of the kind of the Databricks data intelligence platform is Unity Catalog, which I consider kind of the brains or the intelligence layer in the entire architecture. So Unity Catalog sits on top of that unified Lakehouse architecture that we just talked about, and all of those sources bringing data into the Lakehouse. And it makes sense of it, right? It has the traditional capabilities of a catalog around access control, auditing. Things are really critical for security. But then we have a broadened set of capabilities within Unity Catalog that go beyond that, that allow for collaboration. So for example, discovery of the different data estates or different data sets across the data estate, and being able to share those within your organization or even externally outside of your organization with security. Unity Catalog helps you understand the lineage and the quality of that data. So as these pipelines are growing and evolving and integrating new sources, you want to keep an eye on the quality of the data being maintained, again, so that end users of the data have trust in what they're looking at. And then you want insights. Unity Catalog provides insights about your own usage of the system, right? So granular cost controls, being able to map all of the data layer to the actual business semantics, the things that are contextual about your business processes. So all of this is powered by Unity Catalog, and it gives meaning and insight into the data that's then used by the rest of the platform. So one of I kind of think of the next few things I'm going to talk about as the applications or the workloads that run on top of that foundation I talked about of the unified data layer and Unity Catalog. The first one that we see most customers adopting are use cases around analytics and business intelligence. And so Databricks has one of the most compelling or the most compelling data warehousing offering in the market. And we really lead the market on three dimensions. One, world-class price and performance. So there's a number of different third-party benchmarks out there that look at this. But Databricks has performed 10 times faster than the alternatives in high concurrency situations. That then leads to lower TCO. So on top of the performance, we also have, as I said, AI embedded in each layer of the platform that enables us to do predictive optimizations of the underlying infrastructure. So based on the patterns of your queries, how your business runs from a data warehousing perspective, we're able to tune the infrastructure and those queries, or offer you the option to do that so that you get the most cost efficiency out of it. And then we're broadening and democratizing access to the insights. So formerly you had to have a data analyst skill sets, maybe be familiar with SQL. We are embedding, again, AI into the user interface, the user experience within DB SQL, our data warehousing product, to allow end users to use natural language to query the data. And so this is going to open up opportunities for a broader set of users in the enterprise to be able to take advantage of Databricks and the data intelligence platform. And you can see a wide variety of customers around the world who have taken advantage of this. So the next application or workload that I want to talk about that sits on top of this platform is AI, right? Specifically Gen AI. Increasingly in the last several years has been a top priority board level initiative for most of our customers. The first thing that we like to highlight is this distinction between general intelligence, which is what we as consumers experience when we use some of these leading LLMs and generative AI tools out there, where you have these massive models that are trained on the entirety of all the data on the internet, essentially. These models are really powerful for generalized use cases, but we see a distinction between that and what we call data intelligence, which is where you're building AI, where you're building agents that reason specifically on your data that is contextual and domain specific to you and your business. This requires understanding of your data. And so different from models that are trained on large, kind of general sets of publicly available information, we want to help customers not only with that, but also specifically with use cases specific to their data and their domain problems. So really we think about this as a system, right? And we have all of the components within the system to enable customers to do exactly what I just described around combining the benefits of general intelligence with domain intelligence that's specific to their business. We believe first that this starts with the data. So the whatever agents or AI you're building, they're going to reason over your data to give you that unique differentiation. And so the first thing you have to do is kind of the core of Databricks, which is to prepare that data. So that's really the first step in the process for us. And we have the entire, platform and the pipelines that are bringing your data to your AI. The second thing is building those agents, building those models. So again, leveraging the power and the uniqueness of your data to build custom models or fine tune existing models out there. But this is what's bringing the intelligence that we talked about into your specific models and allowing you to combine those if you want with those more generalized models. And then we think about the deployment of these models of these agents, right? So scaling the infrastructure to enable the best experience for end users in terms of serving these models. And then having the whole pipeline to measure the performance, the accuracy, the user experience with these models, understanding how changes in the model's behavior and performance might have to do with the lineage of the underlying data. And then evaluating those agents to understand, are we providing a good experience? Is there correctness in the output of the models? We have capabilities within our Agentbricks platform, such as LLM judges, that actually leverage LLMs to judge the outputs of the existing models that customers are deploying. And then based on that, if needed, retraining or deploying new versions of those models that iteratively improve the quality and the output of the system. And then all of that is supported with this layer, again, of governance provided by Unity Catalog that provides guardrails, rate limits, tracks usage, all the things that an enterprise needs to put these models and systems into production at scale. So the last thing I want to highlight is a partnership that we announced earlier this year that is really compelling for a specific type of very mission critical data, and that is SAP data, which the vast majority of enterprises around the world are using to power the most critical business workflows. So SAP is one of the leading sources of data and AI, really valuable data and AI source material in the enterprise. SAP systems power the most critical business use cases, whether that be HR, finance, supply chain. When SAP is deployed in the cloud, a number of different analysis show that customers are able to get more value out of that. And as I said, the SAP data sets are really rich foundational data for training AI models for agentic workflows in those same domains I talked about. So agentic workflows that will transform the way finance, HR, and supply chain work. But it's not easy to do, or at least historically it hasn't been. There's really high cost involved in trying to extract data from SAP to be able to combine it with other data and build these solutions. You have data drift because you have multiple different data silos that are replicating SAP data. And so it's difficult to maintain ground truth around that data. And then all of that has caused customers to miss innovation opportunities by getting this data out and combining it with AI applications that power new capabilities. We've partnered with SAP, and I'll talk more about the details in a second, to natively integrate Databricks into the SAP Business Data Cloud platform. And that's offering customers the ability to open up that data. So to combine SAP data with external data, leveraging Databricks to bring together capabilities needed for those agentic workflows, ensuring that we address the data drift problem and with Unity Catalog, ensuring the quality of the data and the security of it. And then, as I said, if you can do those two things, then it enables you with our Gen AI capabilities in Databricks to take that SAP data and build domain-specific AI applications and agents, building on the SAP data and process and workflows. So at a high level, the way to think about this is SAP Business Data Cloud is a first-party product from SAP that brings together their business warehouse, their data products, their analytics and planning suite for a number of different applications, and uses Databricks as the Gen AI and BI layer against those application suites. So you get the best of SAP in the cloud, and you have the ability to take all of those intelligent applications within SAP, all of that rich contextual process and business and supply chain data that SAP has had for years, and apply the best of Databricks in terms of our business intelligence and Gen AI layer to that data to build advanced analytics and Gen AI solutions on top of the SAP data. And then we have customers that want to focus on the SAP data, but they want to do so in the context of other data they have that's not SAP data. So maybe they have IoT data that they want to combine with the SAP data, or maybe they have e-commerce data that sits outside of SAP that they want to combine with their finance data. We have the ability through our Delta sharing capability within Databricks to share data, zero copy between SAP and a customer's standalone Databricks environment to enable those use cases where the power that I'm trying to unlock is the combination of SAP and non-SAP data. So that said, I want to just spend one more minute wrapping on how do we help customers succeed with all the best that the Databricks platform can offer. And really, we think about it in three areas. One is we have the tools, not just the technology, but the frameworks, the migration tools that help customers move from point A to point B in terms of their transformation on this data journey. As you are going to see with the rest of this enablement session here today, we have deep technical enablement, both what we're doing here today and even beyond this with our learning and certification paths that help customers understand the value prop of Databricks and how to deploy it and drive success within their own companies. And then to support you with that journey, especially as you think about that broad scale transformation and implementation, we have hundreds or thousands of partners who are experienced, who have built out Databricks practices, who can help you take Databricks and your existing architecture, bring those things together to help you drive this transformation forward. And ultimately that at the core of that is enabling our customer success. So that said, just wanted to kind of introduce you all to Databricks. I know Alexander will do a good job of taking you guys deeper into that, but hopefully this has been informational. Thanks.
All right. Thanks, Will. I guess that means it's all up to me now. Sweet. I think we're ready to go. You can all hear me, right? 200 of my closest friends. Let's get to business. All right. Thanks again, Will, for that introduction into Databricks. I think some of my favorite questions whenever I start talking to customers or prospective customers is, what is a data brick? So hopefully that gave you a little bit more definition as to kind of what Databricks does, kind of where it sits in the data ecosystem. Yeah, short story everywhere, right? So today we're going to work through a couple of labs and get you some hands-on experience with Databricks. If you're excited to do data engineering, machine learning, maybe even some Gen AI, or if governance is your favorite topic, then I applaud you. I mean, we all love our governance and networking, right? So this should be a good couple of hours here. We'll take a few breaks. I'm thinking maybe at the top of the next couple of hours, we'll take a quick 10-15 minute break before we jump more into things. Let's see. We also have a couple other folks on the line, Stefan and William. So please, please, please don't be shy in the Q&A. Drop whatever questions you have, whether it's about Databricks in general, data and AI, big data, best practices. I like putting the TAs to work here, so please go in. Let's see, who am I? I'm Alexander. I'm a solutions architect with Databricks. I work in the digital native sector, but also have a lot of experience in sports analytics. Before Databricks, I was a practitioner. I use Databricks every day in my old job, and I used to work for a professional sports organization, which was a pretty cool experience. So seeing the gambit of how Databricks is used across all sorts of industries, CME, retail, and of course, digital native and kind of technologies. So excited to be with you here today. I also have a background in enablement, and hopefully we all learn a little something today. So we can all say we grew and improved ourselves on a random Tuesday in November. All right, let's get after it. Let me see. Q&A. Does Databricks offer any product to build semantic layer? Ooh, actually, yes, it does. But hopefully we'll talk a little bit about metric views a little bit later today. All right, I got 11:25 on my clock. I'm in Central Time, so I'm going to be running off this. So it's almost 9:30 Pacific, so let's get moving. All right, first thing we're going to do is introduce Databricks Free Edition. Databricks Free Edition is exactly what it sounds like. It's a free environment of Databricks where you can be hands-on and you don't have to enter a credit card and everything you do gets billed to Databricks. So honestly, it's the best of all worlds, right? There's actually a lot you can do in Databricks Free Edition. If you were familiar with the old Community Edition, Databricks Free Edition is at least 10 times better, just in terms of the amount of compute, the amount of data we can process, and the amount of features available. I think almost everything is available in Free Edition, even interacting with some generative AI applications too. Obviously, you can't just load up Claude Opus in Free Edition and kind of burn through a million credits, but besides that, I think we can do almost anything. So let's get our account set up here. I'm going to drop this link into the Zoom chat. I think Sophia also may have dropped it in earlier as well. Boom. Databricks.com Learn Free Edition. And what we're going to do, if you have never used Free Edition before, then click the big red button to sign up for Free Edition. If you have used Free Edition before, then we're going to click on Log In here. I'm just going to click on the big red button so you know kind of what it looks like. And you'll see with Databricks Free Edition, you can learn professional data tooling on Databricks for free. I recommend utilizing either your personal or professional, I guess, Google or Microsoft account if you have one. For this workshop, I actually created a dummy Databricks email. I guess you can email me at that email if you want. So here's my personal email that I'm using for the workflow today, workshop today. And welcome back. It found me. Yes, I exist. So we're going to load up into our free edition workspace. We'll give you a minute or two to catch up here. I'll also review kind of how we did that. But if all goes well, you should hopefully see Databricks on your browser. We recommend utilizing Chrome or Firefox, but honestly, if you want to use Opsera, like whatever, go for it. You should also see Databricks Free Edition up here in the top left. So we'll do a quick overview of what Databricks actually is and kind of working our way through the homepage here in a minute. But again, for those of you following along at home, let me quickly review how we got here inside of a free Databricks ecosystem. First thing we did, we went into the chat. We grabbed our link, databricks.com/learn/free edition. And we went to this homepage right here. Next, we clicked sign up for free edition. I recommend utilizing a Google or Microsoft account, but you can also just use any email. Doesn't really matter. I think if you do any email though, it may send you an email. So it may take a minute for kind of that authentication to persist. But either way, sign up for free edition. I recommend just using a personal or professional email here. I'm using this guy right down at the bottom that I have for workshops. And once you click on that with Google, it automatically does all the authentication for you. Same with Microsoft. And then it should just give you a new account or just a default account for your username. And when you click on that, it should hopefully bring you to this homepage. Quick thing just while y'all are loading this up, Databricks Free Edition, even though we talk about it for enablement and learning, it's also pretty good for hobby work. I actually have some like free edition accounts. Maybe I shouldn't say this on the recording, but I have some free edition accounts on my like personal laptop and stuff that I do some hobby work in, which is kind of fun. I mean, it's not often you get access to free compute, right? Even if it's a little bit rate limited, like our free edition. Cool. I think, let me check the Q&A, see if anyone's having a bunch of trouble. How can I open this welcome tab in the Databricks Free Edition environment? We haven't, it just should show up by default as the homepage. If you got here and you were like clicking around in your workspace or something, you can always click back on the Databricks icon in the top left to take you back home. If you already have a corporate Databricks account, do you need to create? Yeah, I would create a new account in Free Edition. Just because we don't want to actually impact anything with you in your corporate workspace. You can definitely run the workshop in your corporate workspace, but I would recommend doing that outside or after the workshop, just because I don't want you to incur charges if you don't have to, right? Free edition is locked. Again, if you need to reset a password or if you used an email that's not Google or Microsoft, you will need to update your account, reset your password, and kind of log in. Again, if you use a non-Gmail or non-Microsoft email, it may take a minute for that authentication to be sent to wherever your Outlook and stuff is. And I'll let the TAs answer the first question, how Databricks differs from other competitors. It's a good question, though. Let's say in my personal experience, the beauty of Databricks and the Lakehouse, if we're gonna nerd out today, I'm gonna call data ecosystems beautiful, I guess. But what makes kind of Databricks like pretty stand out to me is, and like why I chose it as a data architecture when I was a practitioner, was just the idea of kind of being open source. You control everything. If you don't want to use serverless, you control the compute in AWS that you're using your EC2 instances. You control your data, open file formats. I can log into my S3 bucket, see my Delta and Iceberg tables, and be like, yes, I own this. So that was really compelling to me, as well as Spark, and that, of course, being open source. And then coupling this idea of being open source and giving you full control of everything in your data estate. Coupling that with this idea of what exactly is your data estate, right? And that's why Databricks moved to this idea of a lakehouse, data lake, data warehouse. Your data shouldn't be disjointed, right? If you have all your structured data in a big data warehouse like competitor XYZ, but you have all your unstructured texts, PDFs, videos, semi-structured JSON blobs, put in whatever cloud storage you have as well. Maybe you have that kind of loaded up into a NoSQL store somewhere. Now you have real disjointed data sets, right? You have cloud storage buckets for your unstructured data, NoSQL databases for your semi-structured data, and cloud warehouses for your structured data. How do you put governance across that? How do you train models in a centralized location? And especially as we kind of moved into the generative AI era, I think it's easier to bring your agents to your data, right? So kind of build the agents where your data is located. Don't have to worry about kind of all that extra permissioning stuff. So if I build an agent in some other system, it shouldn't have to deal with all the networking, egress, and governance to have to go to an unstructured data store, go to a NoSQL store, go to a structured store, right? So that's why this idea and paradigm of a lakehouse is almost ubiquitous now. A lot of Databricks' competitors in the marketplace also offer this idea of a lakehouse architecture. But Databricks was first to market with it, and honestly, I think they've done the best job in incorporating a lot of those features, as we talked about, governance and AI and ML, right? It's almost easier to build your ML models and your AI models in the same place where your data is being engineered, right? So if all your data engineering is happening on Databricks, you may as well do some machine learning on Databricks. Yeah, we'll talk about this as we get into the code. And then last thing I have to say on that, I think for 2025, the big word I've heard in industry is interoperable, which kind of goes back to that idea of being open source. So when I say interoperable, I mean, how well does, we all have other systems, right? You don't only have Databricks as much as I want you to only have Databricks. So how do we kind of play nicely with other systems in your architecture, right? And that's really where the open source file formats is really shown. Will in the intro talked a little bit about Iceberg. I think it's worth pointing out here as well, just because, again, a lot of competitors in the space are now supporting managed Iceberg. So the beauty of this Iceberg file format is that any engine can read it, basically. So if you have cloud competitor XYZ, data warehouse competitor XYZ, they can query Iceberg tables, which is really cool. So instead of having data duplication, your data lives in Databricks and then you have to copy it to another warehouse. You could just have it live once, right? Define your table as an Iceberg table, and now all these other engines can just query natively from it, which is kind of elegant, right, in terms of a solution. So I'll let you do your own research, but if you Google zero copy like data clouds and things, you'll see a lot of stuff related to Iceberg and Databricks starts coming up. And again, that's kind of the same thing with optimizing agentic Gen AI development. If I have a single source of truth and a single file without data duplication across multiple disjointed systems, my agent only has to look at one place, which is kind of cool, right? It's efficient. So I'm a big efficiency guy. If something's efficient and cheap, I would rather use it than have to pay for proprietary, expensive systems. Anyway, that was a tangent. If you have questions on that, put it in the Q&A and we'll let Stefan be busy. All right, let's get into our workspace. Hopefully you've all signed up by now. I have dark mode on. If you want to add some extra things here, you can actually go to your settings. So I clicked my little A in the top right corner, went to settings, and here if you can change your preferences, you can change it to be dark or light mode. Oh God, it burns. Let's go back to dark mode. But if you like light mode, that's where you can change all of that. You can also set up your language here, as well as link to things like your GitHub if you want to do that, again, for some of your hobbyist work. You can also declare your API tokens, PAT tokens, and other things here. I'm not gonna change anything in the settings tab yet, but again, I wanted to show if you wanted to change your Databricks to dark mode like me, click your thing at the top right, go to settings, go to preferences, and then you can prefer dark mode or use system default. All right, back to the Databricks homepage. You'll see that the first thing you should see here is our introduction to Databricks. What is Databricks? We got some fun little videos if you want to watch these on YouTube after class. I promise there won't be a test on it. We also have this idea of connecting to data. We'll talk about that more in a second. And we also have some crash courses on your persona, right? Are you more of an analyst? Do you want to know SQL? Do you want to use distributed kind of computing for large data queries? Are you ingesting data? Are you transforming data? How can we best do that using Databricks and big data best practices? And of course, if you want to build agents, build models, use the power of LLMs, we also kind of have our native Gen AI course on here too. That's like one other quick point about where Databricks fits into the market. We've taken the stance of being Gen AI agnostic, right? So whatever vendor or server you want to use, whichever AI applications you want or LLMs you want to utilize, we will allow that, right? We have partnerships with Google and Gemini. We have partnerships with OpenAI. We have partnerships with Anthropic. A lot of really cool announcements happen there. So even if you're on AWS and you want to use a Gemini model, I'll say, let me see if any of these are actually available right now. You don't have to click on anything yet. Looks like we didn't give you Gemini, but we have some of the like Llama models and some of the GPT open source models in here as well. Maybe we do have Gemini if I scroll far enough down. But yeah, we'll kind of go over some of these a little bit later in the course too. But the big idea is if you want to utilize whatever LLM you want, Databricks allows that. So there's a new philosophy, and I'm getting off topic again. There's a new philosophy in Gen AI development, kind of known as the model garden, which is you don't have to use one LLM for every single purpose. Every LLM is specialized and is better at certain topics. You don't need to use a massive, really large, really expensive large language model to do things like summarize a Slack message, right? Which maybe I do a little bit too often. But let's say like you have a multi-step agentic agent. You have some of it creating SQL scripts, some of it writing Spark code, some of it summarizing kind of text documents. You can use different language models for that, for each of those specialized purposes. So that's kind of the idea of a model garden. Use multiple models for the best use case possible. And I think Databricks has taken a really great standpoint on being a differentiator and allowing that choice, right? Again, it kind of goes back to you own everything in your data estate. You own the data, you own the models, you own the compute. Same idea with LLMs. You own whatever language models you want to use. You're not going to be forced to just use Gemini or forced to just use GPT-5, right? You can mix and match and find the best one at the cheapest cost for your use case. We'll learn more about that by taking this Gen AI class later. Cool. So hopefully we're all in here. Let's do a couple quick introduction to the left-hand tool pane. This left-hand tool pane, I click on this little burger icon and you'll see that there's a lot of different options here. Again, we tried to organize it more so by persona. So the top options are going to be your larger kind of metadata admin. So what is in your workspace? What data is in your catalog? If I click on catalog, you shouldn't see too much over here. We should just only have this workspace catalog here. Just a little bit of vernacular vocab. Again, this won't be on the test either. When we say catalog, we essentially mean like your database, right? It's just an organizational thing. So we call it a catalog, and within a catalog, you have schemas. So for example, within the workspace catalog, we have the default schema, and within the default schema, we have nothing. But we could have tables, we could have volumes, we could have models, we could have functions and things like that. And again, our idea and philosophy is whatever you create should all be governed centrally, right? Control who has access, control your user groups, control like who's the usage of it, whether it's a machine learning model, whether it's a data set or a data pipeline or a function, that should all just be centrally governed. Yeah, one of my biggest pain points as a practitioner was some of my ML engineers would just like create a random model on their local machine or some other platform, deploy it with some API somewhere, and like anyone could use it. And it's like, well, I had no observation into how the model was trained, if it's even reproducible, where the model lives, what its metrics are, or its usage. And again, like bringing that into a centralized platform that connects with your data estate is huge to me, especially when it can be governed correctly. Let's see what else we got. Compute's kind of fun. Again, if we were actually in a corporate Databricks environment, you would have full capabilities and permissions to create a classic compute engine, which again is tied directly to your cloud provider inside of your virtual private cloud or VPC. In our case here, we only have a couple of serverless options. We can't even create anything. Because again, we don't really want you spinning up a super massive 16 Excel cluster to burn. Again, notice that I didn't enter a credit card. If you signed up, you shouldn't have entered any payment at all. So I think that's great. A really true free edition. Finally, we're going to have under the SQL side, this is where we're going to start writing queries, creating dashboards. Genie is just our product for text to SQL, allows you to chat with your data. We're going to do a lot of Genie in the next couple of hours. And then data engineering, how do you kind of bring data in? Notice we have connections, kind of as Will mentioned, to SAP, Salesforce, Workday, ServiceNow, SQL Server. We can even connect directly to your cloud storage buckets as well. So definitely recommend kind of doing some more integrations here. We have a lot of partners. Fivetran's a big partner of ours, which I think just bought DBT. So that was kind of fun. But you'll see that they actually have some of their connectors kind of by default provided to us as well. And these all should work in free edition. So if you, after this class, if you want to go back and try and connect to Salesforce, try and do it in free edition. That way you won't get charged and you can see if it works, right? I think that's always the best way to interact and experiment with new kind of software products, right? Is get your hands dirty with it and see if it actually works in your own environment. Finally, we have the AI ML section down here at the bottom. Playground, this is where it's kind of fun. Again, we can actually chat. Oh yeah, GPT 5.1. I don't know if you joined our webinar last week with Sam Altman, but we announced a lot of our partnership with OpenAI. You can see we have a bunch of other models here. Let's say I want to use ChatGPT 5.1. We can say something like, write me a poem about a lakehouse. Oh God, we'll see. Womp womp. It says permission denied. I was gonna say I didn't think I could use GPT 5.1. Let's use one of the open source ones. I'm switched this to GPT OSS 20B. Ah, there we go. A quiet lake house draped in mist sigh. A single-spoked dock, Alfredoed by moonlit pine. Beautiful. Big idea here that I want to show with kind of the open source models, kind of, or the LLM models within Databricks. This lives in your virtual private cloud, right? Again, this is huge. Instead of going to Chat GPT or Anthropic Claude Code, where maybe you're uploading proprietary information, we've all done it. I've never admitted that on recording though. And you're saying things that could potentially be proprietary or PII or something, and it's all on just ChatGPT's application, that's like not really good, right? Again, we talked about earlier about bringing the agents and the models to your data. We should bring the models inside of your network, inside of your security, inside of your governance. And now you can interact with the models with your data all within a secure framework. We'll talk a little bit about the ideas of AI guardrails a little bit later on. But that's the idea again of making sure you know what requests are being sent to the large language models, what the language models are returning back to you, and making sure that you cut them off when they are starting to be used inappropriately or going outside your security requirements. Maybe I should say, give me a haiku instead, because that's a lot of words. I'm not reading that long poem. Lakehouse sits quiet, oars hum beneath moonlit soft. Quiet dawn rings light. Snaps. It's beautiful. All right. Y'all weren't here just to write poetry with ChatGPT open source. So let's get after, so that I get my dog kind of runs around sometimes. All right, so let's get after some real work here. I'm going to go back to the workspace. If you were just kind of dozing off during all that, now I need you to wake back up. We're going to do some real work. Within our workspace, all I did here was click workspace. If you go into workspace, you should be able to go to users and see your user account. When you spin up a Databricks free edition, it's just yours. There's nobody else in here unless you add them. So you should all see just you in your workspace, which is great. It means it's pretty easy to govern if I only have to govern myself. In here, we're going to create a new notebook. You may see some stuff already created for you. I think it automatically creates a usage dashboard and maybe a Genie space. You can ignore all of that for now. What we're going to do is go to this big blue button at the top, click create, and we're going to create a notebook. The notebook is the primary interface for writing and creating code with Databricks. Of course, there's some low code options within the platform. But we're going to actually be pretty technical and hands-on today. So what we're going to do, we're going to install some of our open source and public free demos here. So I'm actually going to go ahead and show you where we're going to be pulling these from. dbdemos.ai. I'm going to drop that in the chat. dbdemos.ai. If you go there, it should route you to our demo center, where you can see all of our different quick start tutorials. And we can even explore all tutorials and see the different kind of options that you have here. So we're going to actually be doing, I think we're going to be doing the customer churn today. So we're going to be doing an overview of the entire Lakehouse platform. That's why this is like a 3-hour session. But if you only cared about some of the data engineering workflows, maybe you want to know more about Spark streaming or declarative pipelines, or if you want to go deeper into Iceberg, right? We have different kind of demos that you can just install in free edition or your corporate workspace as well to work through. Let's say you care about AI and Gen AI. We have how to build a RAG application on Databricks and our best practices for that. If you want to look at Genie or dashboarding, we'll talk a lot about that today. If you want to dive deeper into some of those concepts, you can install some of these other demos into the free edition or your workspace later on as well. So I'm going to show you how to install one of these demos. The one we're going to be installing is this customer churn demo. And if you scroll down, it gives you a little bit of help with the commands that we need to run. So in my notebook, what I'm going to do here is we're going to name it. I'm going to click in this tab icon up here at the top, and let's just say something like install demos or labs or whatever you want to call it. I don't really care what you title your notebooks, but you should title them to make them easier to organize and read. Next, I'm going to click on this connect icon up here. I have a pretty wide monitor, so you may just see a blue dot. You can make your interface a little bit wider. You can minimize the left-hand toolbar by clicking this burger icon, and you can even close out of this little workspace tab right here if you want to close that out as well. But I'm going to click connect on this blue button, and we should have the option to connect to serverless. So again, this is where some of the restraints in free edition comes into play. You can only have 2 notebooks running serverless at the same time, so you only get 2 parallel jobs, and you don't have any customization of a cluster you can create. You're forced into our serverless. But our serverless is pretty good. Again, in free edition, you should be able to process millions of rows, and I think one of our co-founders posted on LinkedIn yesterday. I don't know if any. I'm talking to Stefan's headshot on Zoom. I don't know if you saw this, but it's like he said it was. They said we could use billions of rows in free edition, and I was like, why are you pitching that? Like, no one's gonna use the corporate edition if you can do billions of rows in free edition. But anyway, little enterprise secret for you. All right, so let's start with our first couple commands here. The first one is going to be this. Where are we? Pip install db demos. I'm going to copy that over, or you can type it out. We're using a % to make sure that our notebook knows that we're running this as a command line operation. You're going to notice that within a notebook, we can actually switch between command line, Python, SQL, even Scala, which is kind of fun. So you can have one notebook that you can quickly switch between languages. And then you do need to do this, so you do need to follow along. If my voice has put you to sleep, I do need to do some work now for me. So we're going to pip install this db demos library. And this should take just a minute or so to run. And they're going to notice at the bottom, it wants us to run this command %, restart Python, or this dbutils command. So I'm actually going to use the second one. Let me actually copy that. And then I can drop these in chat as well if you don't want to type. So here's the first one. And here is the second one. Notice that this is a Python command as opposed to a command line command. And once we have restarted Python, the next thing that we're going to do is actually install this demo. We can import db demos and then install it. Note that I'm going to actually make one quick change to that. I want to actually list our demos out. So I'm going to plop this into the Zoom chat. And let's drop this in. So we're going to import this DB demos archive, and we'll list all the demos available to us. And it should give us something very similar to the DB demos .ai, where we can quickly kind of scroll through and see all the different types of demos that are available in the library. Light mode, gross. Cool. So we're going to be installing the churn example, like I mentioned. So we can copy and bring this over. Notice that we will need to change a quick thing about this. So notice the installation. When we install the demo, we have to specify where we want to install it. So if I click on the little shape icon here in the bottom of my toolbar, it's like the circle, square, triangle. If you click on that, it'll give you a quick interface into your current catalog. I personally like having the catalog open as a new tab. Again, I'm right-clicking, open link in new tab. But the first thing you should notice is that this catalog main does not exist in our free edition. We only have this workspace catalog and then the system one, which we shouldn't touch. That's like read-only. So we actually need to change catalog main to catalog workspace. And then the last thing that I would recommend adding here is overwrite equals true, just in case you want to run this again in a future life. We need to overwrite any existing installation. So I'm going to kick that off, and then I'm going to drop this in chat. This will take a few minutes to install, but what it's going to be doing behind the scenes here is going to be installing some notebooks for us. And then these notebooks will actually also be kicking off jobs to ingest and interact with data, as well as create some pipelines and even do some machine learning modeling for us. So in our work over the next, time's at 11:50, over the next hour and a half, 2 hours, we go till 2 o'clock. So yeah, over the next couple of hours here, we're going to start working our way through those notebooks. We'll run some of them, we'll read over and skim through others, but hopefully you should get a full end-to-end example. Again, a pretty technical example of what the Lakehouse looks like, right? How do you bring in data from source? How do you create data pipelines to put those into Delta, these open file formats? How do you build machine learning models on top of that data? Again, govern all of it, your models and your data. And then finally, bring your end users to that experience as well. Create dashboards, create these natural language spaces. And if we have time, there's a little bit of Gen AI on there, but I may leave that as an exercise for the reader to do on your own time. All right, Q&A is quiet. Love it. And we still got 220 of y'all, so that is great to hear. All right, you ready to do some work? Let's get after it. So just do some stretches, get your water in. All right. I am going to go back to my workspace. So all I did there was I clicked out of this notebook interface and I clicked workspace over here. And then we're going to open up this Lakehouse Retail C360 folder. And the first thing we're going to open up is the 00 Churn Introduction Lakehouse. Again, this will take me back to the notebook. Another way to open this folder is on the left-hand tool pane within your notebook environment. You can click on this little manila folder icon, and then that'll actually give you your workspace, your file explorer, your finder type of thing within Databricks, your user workspace to be specific. So if we open up this Lakehouse Retail, you'll see we have a lot of stuff: ingestion, governance, AI, BI, machine learning, and then we probably won't get to the Gen AI stuff, but it's kind of interesting. And then our full 00 churn introduction here. So we're going to read over this real quick, and then we'll kind of get to work. All right, so what are we doing in this demo, in this example? So this is an end-to-end demo that shows the full integration of everything within Databricks, right? How do we do our data engineering at scale within Databricks? How do we do machine learning at scale or in a distributed way on Databricks? How do we do BI, warehousing, and generative AI on top of that? And of course, govern it through the open source Unity catalog that we have. We open sourced it last year, I think. All right. Databricks allows you to create value from your data. There you go. What is a data brick? All right, a lot of interesting. I liked what Will said at the beginning when he flashback to an hour ago when he was talking about data intelligence and what that actually means. I think it can intelligence can always mean the decisions that you make off of your data, which I think is the most important. Again, why do we even have data platforms? Why would you buy a data brick? It's to make smarter decisions at the end of the day, right? We want to be informed with the decisions that we're making. We want to have confidence. We want to understand the uncertainty in our data and our models. And we really just want truth. We want truth telling, storytelling, decision making, right? That's how you compete with analytics. So with Databricks, when we think about intelligence in terms of your data, it's more so about optimizing and making that decision making more efficient, right? Again, we talked about having disjointed data silos that limits intelligence because it limits efficiency. It makes it harder to discover your data sets. It makes it harder to make decisions off of those data sets. So with Databricks, we really think that bringing everything together in an open format in an open place that you own and you control really helps just makes that intelligence faster and more efficient. And further, because we integrate AI within the platform, it makes it easier to do things like data discoverability, accelerate agentic development, all of that good stuff. How do we increase your focus on optimizing the business, optimizing the decision making, as opposed to getting into the minutia of, oh my God, my job failed again. Why did my streaming pipeline lose a checkpoint? Why is this AI model kind of saying a bunch of hallucinations? Get to the meat of the problem. And at the end of the day, the big idea is how do you make decisions better, right? And again, we want to make it simple and secure. So here's what we're going to be doing with our generative, with our solutions for customer churn here. We're going to pretend that we have a lot of different personas, right? We have a lot of people on our team. We have John, our data engineer, Emily, who's in charge of data governance, Mark, who's in charge of data science, Alice, who's a BI analyst, and Lisa, who's our Gen AI engineer. We want to provide and solve this fragmented customer data that's currently in our legacy systems. Again, we want to make this into actionable insights. I love that. Throw that on your LinkedIn after class. So John, he wants us to use open source declarative pipelines to ingest and control data. We'll spend a lot of time talking about declarative pipelines here. Then we want to implement Unity catalog rules to enable proper data governance, actually have RBAC and ABAC access controls, maintaining your lineage and compliance with international and national protocols. And then finally, utilize SQL Analytics to create dashboards and make those decisions off of the data sets. Finally, we want to utilize Mosaic AI to integrate with your classical machine learning models, your XGBoosts and random forests of the world, as well with your generative AI applications as well. All right, so we're going to start with ingesting our data using Lakeflow. So with Databricks, everything's always named after a lake. So we have Lakeflow and Lake Watches and Lake Bases these days, which is kind of fun. But anyway, with Lakeflow Connect, our goal is to streamline the data engineering process. Databricks' original bread and butter was writing and orchestrating Spark code for you, but Spark is kind of a pain to work with sometimes, and we want to abstract that away. We want to make it easier to come in and start creating these managed pipelines. So we already talked about Lakeflow Connect. That's where we can connect to things like your Workday, Salesforce, SAP data buckets. But we're then going to start writing pipelines, Spark data pipelines. So that's where we're actually going to start today. All right, so let's go look at our data. I have my catalog opened in a new tab. And hopefully I've rambled enough that everything has loaded. So if I open up in my catalog workspace, we should see this new schema. Remember, it's basically just like a database. Your Databricks demos retail C360. And within this new schema, we should hopefully have 9 tables and a volume. We're going to start with a volume. So what is a volume? I'm going to go ahead and click on it, C360. And I should get this new thing pop up here on the right. All that a volume is a governed and managed S3 bucket or cloud bucket. If you're on Azure, I think it's an AWS workshop, so maybe I shouldn't mention Azure too much, but it could be your Azure Blob Storage, your Google Cloud Storage bucket, or typically an S3 bucket for this audience, right? This doesn't have to be just within Databricks. Typically, this is an external S3 bucket that you own and you control in your cloud. And you're going to see in our S3 bucket, in our bucket right here, we have these subfolders. And if I open up users, you're going to see we have all of this Parquet data, JSON data. We have all this JSON data that we've dumped into this bucket. So maybe in another pipeline somewhere, you have an API request that's going off to an API, getting a JSON blob and writing it to an S3 bucket. We can even see what this kind of looks like. If I just click on this first one, here is kind of my JSON about Rachel Clark at parks.com, wherever Hannaford is in the US. So we have all this information about these users. So this is our raw data, right? That's typically what this is called in the industry. We have all of these different raw features, these raw data sets that we need to start ingesting. Notice in this case, we have CSVs. So we have a mix of data types. We have some CSVs, maybe grabbed from an FTP server somewhere. We have JSON, maybe grabbed from an API. I've also seen Parquet. You can even have like other kind of unstructured files, TXTs, PDFs, whatever, right? Dump everything into a bucket. And now we can start interacting with our pipeline to start ingesting this data in. So you can already see kind of where we're going to go with this. If you open up the tables, you'll see that we have users, orders, features, and events, right? So we have a bronze layer, right? We have our ingested data into a centralized table. That's our first step. Once we've brought that data into a table, then we want to actually transform it into usable data sets. We call that our silver table. I'll go over a quick documentation too here in a sec. And then finally, we want to aggregate, join our clean data sets together to create our BI ready, our agentic machine learning ready gold level tables. So if I pop over onto some documentation for you, I'm actually going to plop this into the chat when I find the right one that I want to do. I'm gonna plop this into the chat here. Yeah, Artem.
Yeah, hi, Alexander. We're getting a lot of questions regarding the fact that folks are not seeing some tables or maybe volume is not yet available. I think it's important just to note that the installation process for the demo takes some time. So guys, if you're running the Python commands that are listed in the chat, please wait a couple of minutes. Once the installation is finished, you will retrieve tables, volume, and other assets available in your workspace.
Yep, there's a lot of background jobs that start running here, and we're going to run some other things as well. But yeah, that's also why I was rambling a lot at the beginning. So my personal one would run a little bit more. But yeah, no, there's some background tasks happening here. Don't worry about seeing the tables. I just, again, wanted to start with this first idea of where data lands. And notice it's already landing in a place that's governed within Databricks, right, with this external S3 bucket. And we're going to walk through how these tables are going to get created here in a sec. But I wanted to go over a few kind of vernacular things. So again, I just dropped into the chat. You can keep this for your extra work. This is about the documentation on different ways of ingesting data into Databricks. So I like this idea of batch for streaming, right? Are you ingesting data every hour? Are you streaming data constantly in? And more specifically, let's get to kind of the medallion architecture. So medallion architecture is what I just mentioned. Typically, you have your raw data that's dumped somewhere. Then we load it into bronze, which typically is a mirror of your raw data location, but is in a open data format such as Delta or Iceberg. Then we have our ETL processes, our transformation workloads that clean up the data, apply our relationships, apply our data quality expectations, and then our last mile aggregations we call gold. So I've seen a few accounts kind of call this whatever you want. So I've also seen platinum and titanium layers thrown in. It's just our recommendation, but of course, as your organization, you can define how you want to move data between quality assumptions, however you would like. One other thing here before I move into the actual code is this idea of procedural versus declarative data processing. I'll drop this link in chat as well. So this is the big idea here is, sure, I could just write regular stored procedures. Like you can do stored procedures in Databricks. You can write SQL code. You can write PySpark. That's very procedural. It goes step by step, does its own thing. Each of those notebooks may live by itself. But with declarative processing, you abstract a lot of that away, right? So with declarative processing, what we believe at Databricks is that this reduces the complexity of your different systems, makes it easier to debug and track, automatically integrating things like lineage as well as workflow, metadata, and audits, and really just automates things like query planning and dependencies. So with declarative pipelines, or what we call it now Spark declarative pipelines or Lakeflow declarative pipelines, we find it's a more simple way to connect the dependencies of your multiple data streams. So that's what we're going to introduce today. I'm actually going to show a small example of procedural data engineering here as well. But yeah, one of our big announcements from over the summer was open sourcing this idea of declarative pipelines. So yeah, we open sourced declarative pipelines back in June, which was a pretty cool thing and got a lot of buy-in from the Spark community as well. And you can see kind of this is the idea of what a declarative pipeline allows you to do. You can ingest data as streams or micro batches from your buckets. And then from there, you can create your silver views and then finally your aggregated materialized views as well. So let's see what this looks like within our churn example. We've gone over all of the different data sets. Again, I'm on the volume here. We've gone over the different data sets that we need to ingest. If I go back to my folder icon and open this data ingestion one, let's start by reviewing this 1.1 SQL notebook. There's a few things to explore here. I'm going to open up the 1.1. SDP stands for Spark Data Pipelines. Our goal is to help John optimize his life, make it easier for him to ingest all these files, not have to worry about some of the micro nuances around small files, GDPR, and complex DAG dependencies, and make sure we can start enforcing data quality as well. So if we scroll down, we'll actually see some of the code here. But you can see kind of the example of what we want to build. We want to load this data in through Lakeflow Connect or whatever, or through our buckets, clean it up, join it ready for modeling, and then create our dashboarding off of it. And if we scroll down, let's go to our exploration. We'll come back to this notebook in a second. You can either click on this hyperlink or you can actually click on the exploration notebook. And we can actually run some of this to see what our data looks like. Again, this is similar to what we just did in the UI, but we should be able to run this notebook. So again, all I did here was I went to 1.1 explorations and then opened up the sample exploration notebook. Let's connect to our compute. And we should be able to look at some of our data sets here. So again, we're just looking at our raw data. And again, this raw data can come from Lakeflow Connect, from APIs, from FTPs, really whatever. And again, you don't have to run this notebook, but I like to do it just to kind of see what the data looks like. And again, behind the scenes, this is running Spark, and that's actually a pretty cool thing to just reference. We mentioned that the Spark syntax and Spark API can be kind of annoying to use. So with Spark SQL, you can write SQL commands that actually get distributed behind the scenes to do the Spark workloads themselves. So that's why we'll see that our data pipelines, if you just write them in regular SQL, they scale to meet your data size, whether it's terabytes or I've even seen petabytes of data ingested in backfills. So here's what our JSON data looks like in the user accounts. This is what it would look like in a tabular form. Again, we actually in the UI looked at it in its raw file form. But we can do the same thing for orders and events. I did Shift Enter on my keyboard to run both of those cells. And again, all we're doing here is previewing the raw data in our cloud storage bucket. Cool. So if all goes well, you should see that we have all of these different data sets. And also notice that it didn't matter if I had CSVs or JSON. Spark, it can ingest any data type, really. So we were able to really open up all of these. I've also seen like Excel files and other kind of raw data files be ingested pretty easily using Spark. All right, so now that we understand what our raw data looks like, let's go back to our 0.1.1 notebook here. What it's going to show us then is now that we've explored our data, we need to define and ingest our bronze layer. Remember, our bronze layer is typically a replication of our raw data storage layer. We want to mirror as files come into our bucket. We want to make sure that those files are ingested into some kind of staging table first. So when we load this up, we can see that we want to create bronze tables for our events, our orders, and our users. And perhaps these came from Google Analytics and SQL Server and Salesforce. Note that we can also ingest through streaming services such as Kafka, and we actually have a new product called ZeroBus that can do Kafka and Kinesis streams pretty easily as well. Again, it's a little bit out of scope for today. But with our Spark auto load, with our Spark autoloader system, we automatically handle things like schema inference and evolution, change data capture, millions of files and scale, and again, just overall simplicity. So let's go ahead and look at how we define our bronze tables. Again, note that we're not going to run this notebook yet. This is actually just going to be a task that we're then going to execute in a pipeline, right? In a job, basically. So let's look at the code that we wrote here. And again, we can see that we are defining our app events table as select star from cloud files. We're going to load up from this volume. We're going to specify that it's a CSV, and we're going to infer our column types. This cloud files in SQL is important. It is the autoloader command that only runs kind of within Databricks SQL to be able to ingest this data as is. Notice we have the same thing for churn order bronze. This is loading in the orders data. And again, we specified that we want it to be streaming, which essentially is just append only. This isn't like a real stream where it's running nonstop. Basically, as new files get in, we want to append them to this table. We'll then drop duplicates and do other data quality constraints in our silver layer. So here we're loading in our orders data as JSON, and finally our user data as JSON as well. Again, we're not going to run this. This is just a flat SQL file that we'll end up using as part of a pipeline. One last thing to note is this idea of a comment. This comes back to this idea of data intelligence that I dropped a hint about earlier. So with this comment, we're adding semantics, right? We're adding our descriptions and our business knowledge to the tables. We're defining what these tables are. We're adding raw text on what they are and what they can do. And this is great because it allows us to start integrating AI, or as we start using text to SQL, our agents behind the scenes know your semantic definitions for these tables, the columns, etc., that can help it find that data discoverability faster. Cool. So again, we're not going to run this. I just want to define kind of what our first layer looks like. If we go back to the 1.1 SDP churn here, we're then going to start talking about our silver layer. With our silver layer, what we're doing is enhancing and enforcing data quality. You're going to see that we're going to be adding expectations. We're going to be also adding relationships if we want to. I think there's a link to a demo on primary keys and foreign keys, which, yeah, you can actually do with Databricks, which is kind of cool. But yeah, we want to enforce that our data is good. This is also where we can drop duplicates. For example, let's say you have an updated record, maybe your updated user data or information. We want to make sure we have unique users only in that churn user. So let's go take a quick look at how we're defining our unique tables. Note that we're only declaring two silver tables, the orders and users. This is because the app event, as it comes in, I guess, is assumed to be clean, which I would never assume. I assume that all data is bad and ugly until I get my hands on it. But in this example, you can assume that the app events data is clean and ready to go. So again, I've gone back to the transformations folder. I've opened up the silver.sql. Again, we're not going to run this. This is not a notebook. It's kind of a flat file that we're going to use as a pipeline. And we're going to see that we're going to create a new table for churn users. We're going to define an optimization Z order column. Essentially, this is kind of a way to quickly enforce things like your query performance. Not really a primary key, but we want to make sure that everything is ordered behind the scenes by ID. This makes it easier for Spark to query later on downstream. So here, notice we've done a few things. We are hashing our email. We are fixing some data types with the creation date and last activity date. We are standardizing the string initialization and capitalization for the first last name. And again, we're fixing some more data stream or data types down here. Also note that we are ingesting this create table from our bronze table. So once our bronze table gets appended to, then we're going to update this downstream table from it using kind of these requirements and constraints. Speaking of constraints, let's look at our first expectation that we've added here. We want to expect our user ID is not null. As we're pulling new data from the bronze table, if we ever see a user ID be null, we are going to drop that row on violation. Kind of dramatic, but we're going to get rid of it. And as you'll see, we actually have kind of like a jail cell for bad rows that violate our constraints that we can interact with. Notice that if you wanted to do a merge upsert in your silver tables, that is also supported, but it's a little bit more complicated and out of scope here. So again, that's going to be that update. Maybe you get a new file for a user that's been updated, and we want to merge upsert that user into my silver table. Finally, we're also doing the orders data. Note that we have two constraints here. We are expecting the order ID to not be null, which essentially is going to operate as our primary key, and our user ID, which is going to be our foreign key, essentially. We are expecting the user ID to not be null. If either of these constraints are violated, we're going to drop the row. Again, same kind of deal. We're fixing up some data types. We're adding in some comments to our semantic layer, and we should have our silver tables. So far in our pipeline, we should end up with 3 tables. We have our app events that should already be clean. And then we have cleaned orders and cleaned users where we've defined expectations. Finally, we're going to start joining some of these tables together to make them usable for BI as well as modeling. So in this case, we're going to be creating a new table called churn features to be used for our model training. And again, we can go quickly look at what this looks like as this gold.sql file. So if I go into transformations and go to gold.sql, we should be able to see that we have a materialized view here. So this is not a streaming table. This is a materialized view. So again, if you go back to your documentation, love me a good documentation. We should be able to go, let me see if I can find the difference here. So we have some definitions for the difference between a streaming table and a materialized view. So again, the difference is a streaming table, which again, to me is more of like an append only or like merged upsert type table. It's a table that is defined using flows, right? We want to have lineage. We want to have dependencies enacted. We want this to be declarative. A materialized view is essentially just a cached query, just like a regular view. However, it's going to be stored as a cached object, as an actual storage. It takes up actual storage. But the thing about materialized views is that they can be refreshed. And what you'll see with our pipeline, when we hit this materialized view task in our DAG, in our pipeline, all it's going to do is refresh that view. It's going to refresh that query and recache it off to make it available downstream. So in this case, you're going to notice that this view is defined as a query. It's not defined as ingesting from a table or ingesting from a file. It's defined as a query. We're going to be doing some aggregations. We're going to be fixing some or creating some new features. We're creating new feature engineering here. We're creating days since creation, days since last activity, and days since last event. We're joining on our 2 silver tables, based on our constraint on user ID. And then finally, we are able to define another downstream table, which we'll get to, which is going to be the inference table. It's going to contain our predictions based on our churn model that we're going to build here in a little while. So let's see what this actually could look like as a pipeline. Again, all we've basically done is create 3 SQL files. And again, this could basically be kind of what you're doing already with stored procedures and stuff, but we want to make it declarative and we want to make it in our Databricks best practice. So if I go back to the 01.1 kind of documentation notes here at the beginning, if we scroll all the way down, it should tell us that we have a pipeline somewhere. I guess we'll go find our pipeline here in a sec. So let's go find the pipeline. To find the pipeline, I'm going to open up this Jobs and Pipelines option in my left-hand tool pane in a new tab. And again, this is why some of y'all weren't seeing some of the kind of jobs and flows and things. So you'll see that I actually had I think some of the ML stuff kind of failed. We'll do that in a second. But if I go look at one of these pipelines, I think it could be, let's do the SDP one. That's our Spark declarative pipeline. If I go open this up, oh my God, it worked. It's beautiful. So all I did here is I went to Jobs and Pipelines. I looked for the one that said SDP in it for Spark declarative pipelines. And you should see that we have all of these kind of tables defined. So you may be going like, Alexander, Booth, like, what are you doing? Like, how does it know that all these tables exist? How do I even link it to my files? Great question. Essentially, this was created for us already. But if you go into settings, you can kind of see kind of how this is set, right? We define the pipeline name here. We make it a triggered pipeline on a schedule. And then if we scroll down, we'll see the source code. And that is really what's most important here. With our source code, you're going to see that we're going to be located in my transformations folder. So it knows to start executing these as sequential files, and it again, it looks at the dependencies. We know that we're ingesting from our bronze, selecting from our silver, joining with our gold, and it's automatically able to define those dependencies and those lineage. Sorry, I think my headphones may have just cut out. Let me double check.
We can.
Oh, nope.
It's
You
fine.
can hear me.
Yes.
Well, I'm glad you're still listening. I tuned myself out about 20 minutes ago. No, I was kidding. All right, let's get to work. So this looks pretty good here. I think we've done a great job defining this path. If you wanted to do this from scratch, it's pretty easy as well. If we go back to Jobs and Pipelines, you can create a pipeline. So notice the difference here between job and pipeline. Jobs allow us to orchestrate almost anything within Databricks. This ETL pipeline is a Lakeflow pipeline. And again, it gives us that same interface for the one that I just demonstrated that was given to us earlier. So let's see if this actually works. I'm going to go back to my SDP pipeline, and I'm going to click on this down arrow here next to start. And if we go to full refresh all, this should hopefully, seems dangerous. We're going to kick this off as a full refresh. So what this is going to be doing is that it's going to delete anything that's already in all those tables, re-ingest everything starting from the raw location. So it should be going to the volume, bringing everything in, and then creating everything downstream. So let's see if this works. Notice that the first thing that it's going to be doing is waiting for resources. So this is going to be pulling from our serverless warm pool. So it shouldn't take too long to allocate the resources there. While this is going, oh, look, it's going. I'll say maybe I won't move off of this. Again, you don't have to actually run this in your own. I am, so hopefully it works. But again, this is more so demonstrating kind of what this declarative pipeline looks like. And again, I want to show one other quick thing, and then you've all earned a break. So give me 4 minutes, and you've all earned a great break here. All right, maybe while this is going, I'm going to go back to my notebook interface. What I showed you was Spark declarative pipelines using SQL, but this exact same thing can be done using Python and PySpark as well. So again, we want to be cloud agnostic in our way of creating these pipelines, language agnostic. So if I go to the same thing, if I go to the transformations, you'll see that I still have the same bronze, silver, and gold, but now the expectations, the table, the semantics, and the code are all written in PySpark. So if you're more familiar and comfortable using PySpark for data engineering, we can create the exact same Spark pipelines using the PySpark syntax. So you'll see, to me, I feel like this is a little bit easier to read. We're going to be using a stream to read from this file location, this volume cloud bucket. It's going to be a CSV, and we want to infer data types. Same thing for the JSON location, and same thing for the user location. And then same idea for silver. It's going to be all defined using PySpark. So again, if your like eyes are crossing over, I told you the PySpark syntax can be a little bit messy sometimes. But you know, it's the exact same thing that we did in SQL, right? We're hashing the email. We're fixing our data types. We're standardizing our strings. And again, to me, this is kind of why I like Spark so much, is that like I can use SQL and this will all be distributed behind the scenes for me. It doesn't matter. I'm not constrained by my data size. I'm not constrained by my language of choice here. We have the same expectations that we can add to our silver tables on not null. And then finally, we can create our materialized view here. We're specifying it as a materialized view by aggregating and joining different tables together. And again, this is all using the PySpark syntax. So pretty cool. Again, we could then define our Spark data pipeline as pointing to this folder, and it'll again automatically know all of these dependencies. While this is still initializing, the last thing I wanted to go over is, let's say you hate declarative pipelines. We mentioned that at the beginning in the documentation. You can also just do normal quote unquote data engineering with procedural programming, right? Where you declare the different tasks and the different jobs, and then we can schedule and organize that as a Databricks job through notebooks. So if I open up this plain Spark Delta pipeline notebook, you'll see this 1.5 that we kind of hid away so you wouldn't find it so easily. But if I scroll down, you'll see that essentially what we're doing here is in our one notebook, we are writing the SQL commands. We're declaring the tables using kind of our SQL syntax, create table, cluster by our keys, and then auto optimize, turn on predictive optimization, all that good stuff in here. Then we have PySpark code to ingest some data from our volume, and then declare our bronze products as well. Do the same thing for all of our tables. And then we kind of go down, do our silver tables, and then do our gold tables as well. So what I want you to notice as you start comparing these notebooks is, if you're like me and you've been coding for a decade and you've been just randomly creating your jobs and things just like this, which again, there's nothing wrong with that. Just compare about how supportive and I guess scalable and iterable it is compared to something like a declarative pipeline, right? When I do this, I know my logic. I know what I want to do. I know what I'm doing here. But does Artem? Probably not. So now I'm on vacation, you know, holidays coming up, and my pipeline breaks because I wrote some shoddy code. And Artem logs in here and he's like, oh my God, this is a crazy notebook. I have no idea what's going on. What are all these cells doing? Booth, come on. So that's kind of a problem with procedural engineering. But with a declarative pipeline, hopefully we'll see if this ever initializes. Oh my God, it's running and it's working. I totally knew that would happen. I'm not surprised at all. Of course, my declarative pipeline is working because it's supportable and expandable and much more, I guess, supportable. So this is great. So with our declarative pipeline, we can quickly see some of the lineage as it's gone through. And again, with declarative pipelines, there's really only one way of declaring these tables. If I'm going to create a silver table using SQL in a declarative pipeline, we all kind of have to follow the same syntax. It kind of always has to be declared like this. And this means it's easier for Artem to debug it or to go in and be a team player and make it better, right? It also makes it easier to generate with AI. We'll talk about some of the agentic solutions here. But that's kind of the difference, right? Procedural engineering, it's up to you. You're writing your own code. You're doing all these things. Declarative, we try to abstract some of that away. And again, I mentioned the lineage. So this is the last thing that I want to show to us before we take our quick break. If you go to your catalog, again, I'm going to do this in a new tab and go to our schema. Let's go find one of our downstream tables. So we created this churn features table. Let me go find that churn features. If I click on lineage, you're going to see that we should hopefully have a lineage graph here. Oh my God, it's beautiful. Sorry, I'm nerding out again on UI stuff. But with this lineage and how I got here, I went to this churn features table, which as we saw was one of the end gold level tables in our pipeline. And all the lineage is automatically loaded for us. And if I click some of these plus buttons, I can actually go all the way back to the volume, which is very cool. So let me actually load this up so we can see all the different locations here. And then we can go further downstream. We can see if there's anything beyond it, which there isn't. So now I can see that for my churn features table, I'm pulling data from all of these different streaming tables, all of these volumes. So you can see that we have our bronze tables, we have our silver tables for users and orders, and my features table is derived from users, orders, and app events. And if you want to go even further, we can actually go and check column lineage as well. For example, this user ID from the churn features table is coming from the user ID of churn users joined to the app event or joined to the whatever table this is down here, the churn features one and app events. Same thing if I pick like the address column, we can see exactly where it's coming from. It's coming from the churn users address column. So by using these declarative pipelines, especially within Unity Catalog, all of this lineage is automatically baked in. So we have expectations baked in, lineage baked in, supportability baked in, extensibility baked in. So again, I was really happy kind of when we open sourced this last year. All right, let's go take a quick break. I am going to quickly summarize what we've just done so far. So what we've accomplished was honestly a lot. We have signed up for free edition. We've walked our way through the Databricks platform. You should hopefully know your way around a little bit. We've created a notebook. We've installed Databricks demos. We walked through how to create a Spark data pipeline, both in SQL and in PySpark. We went to the pipeline and we refreshed all where we brought data in from our raw volume all the way through our gold tables. And then we explored how Unity Catalog automatically tracks your lineage and your comments and other things like that. I have 10:35 Pacific. Let's be back in just under 10 minutes or so. So we'll be back around kind of 10:45 Pacific. And last hour 15 here, we'll blast through creating a machine learning model and then creating a dashboard on top of that. So it should be a pretty straightforward end to the workshop here. Thanks for sticking around. I will stick around on Zoom here to answer some Q&A, but stop listening to me. Go take a break, grab some water, and I'll see you back here in about 10 minutes. Thanks, everyone. How do we access the data lineage again? I went to catalog. I then found my table. So I went to Workspace, DB demos, retail. So this is my schema. And then I just chose the churn features table, but honestly, you could choose any of the ones we created. Again, note that some of these like aren't really like relevant to us. But like the churn users bronze, the churn users, the churn orders, churn features, app events. If I choose any of these, I'm going to do app events here. If I go to up here at the top, we can see sample data, which again, I just need to turn on my little serverless warehouse. So we can see kind of what the data looks like in this table. And again, while this is loading, you should also be able to see that this is a delta table. Let me go to details. Yeah, so this is a streaming table, and it should be coming from saved as Delta and Parquet. And hopefully this works for my sample data. I'm gonna go choose the churn features because I like that one a lot. So wait for, yeah, sample data. Hopefully this shows here in a second. Beautiful. Here is kind of the output of what this table looks like. Here's the overview. We have the definition of how it was defined. Again, since this is a materialized view, it actually gives us the query here, which is great if I need to debug or reference that. We can see where it's coming from our pipelines. And if I go to lineage, I should be able to see my full lineage graph, which will show me the full dependencies of everything. While we're here, there's a few other things on this tab I'll just show. If I go to history, I guess we won't go show history, but if I go to insights, we can see like how frequently people are querying against our table. We can also turn on data quality monitoring. This is a pretty new feature that we have. It basically runs automatically in the background to check things like your drift and your distributions of your columns. And then our permissions, and I think that's mostly it. You'll see that we even have some of our AI implementations here. So I can actually do this of our text to SQL, our Genie that we're trying to expose more so in the platform. Let's see if we can identify outliers in total amount per user. Let's see if that works. I didn't actually test this. Sophia's going to kill me if it doesn't work. Oh my God, I think it worked. To identify outliers, we're going to calculate the IQR, and here's the query. Oh my God, great job. So run query, maybe? This is fun. Let's see if it finds any outliers. Ooh, there we go. So we're seeing that these users have outliers based off of the interquartile range to find this total amount here. So we're running text to SQL within the catalog, which is pretty cool. Yeah, this is fairly new. This is like in preview right now. That's the other thing I like about free edition. Sorry for rambling some more. Free edition, we automatically like give you the latest and greatest previews as well. So you're not like stuck with an old version of Databricks. You always get the latest and greatest updated features, which again, in the old community edition was not the case. What else we got? Is it possible to keep the pipeline running continuously? Great question. So it picks up new files as they land in the volume. So again, I like doing things for cheap, coming from a practitioner background. When you set up your pipeline, so let me actually pull the pipeline up again. If I go to my pipeline, my SDP pipeline, we talked about how by default right now, this is triggered. So it requires some kind of schedule or trigger to kick it off. By running it as continuous, the pipeline's always running. So when you run anything as continuous on Databricks or honestly anywhere on any SaaS platform, there's going to be a compute charge for that, right? There's always going to be some compute powering the engine. So in my experience, I would challenge you to determine if your pipeline is really streaming and if there really is business value in having a continuous streaming pipeline. If it can wait 5 minutes, then maybe you trigger it right every 5 minutes. If it actually is streaming, you're ingesting Kafka Kinesis streams, then I also would recommend using things like Zero Bus. Let me pull that up here, which is something that Databricks announced also in the summer to try and ingest the records row by row using kind of protobuf. It's pretty slick, actually. But going back to the actual question, how I would usually do it, if I would probably prefer triggered because you can even do it with micro batch. As you'll see, these pipelines, they can run pretty quickly, especially on serverless and if you declare the compute. But I've also seen it done where your file arrives in the bucket in the volume, and then that does a file trigger. So that can do a file trigger Lambda event, which then like triggers the pipeline for you. So if you're only expecting, if you only want the pipeline to run when new files arrive, and you only know the files arrive, like they should arrive every hour, but you can do a file trigger as well. So you're not kind of restricted on the time constraints. But yeah, I think it depends on your pipeline. It depends on your business use case, and it depends on how much you want to pay. If I'm selling you Databricks, yeah, continuous all the way, man. Run some Databricks compute 24/7. But in practicality, look at the business needs, look at your data refreshness, and triggered will probably be good enough. All right, I'm gonna take 5 or 4, and we'll be back here at 10:45 Pacific. All right. Y'all are doing great work, by the way. I'm so proud of y'all for keeping up. I think they kept the recording on, but I guess I can praise you all on recording. We're probably gonna go in here another minute or so. Let me make sure I know what I'm doing with my life. I think this will be fun. They're like, no, we want to do machine learning. Oh, we'll do it. We gotta help Emily out just for a quick minute. All right, we're back. I'm going, recording is going, video is going, screen share is going. So yeah, we're going. All right. Next up, we're gonna do a quick detour out of our data engineering land, and we're gonna help Emily out on data governance, which is great. You've done all this awesome work, John, to create all these tables and create all these dependencies, have everything be observable and transparent. But we want to make sure that we restrict who can access certain tables and things. So we're going to do that using groups and permissions within Unity Catalog. So when we talk about governance, we talk about role-based access control, which is based on your role or your group, what can you access? And then attribute-based access controls, or ABAC, which is based on kind of the attributes of the data products, whether it's a table, view, model, function, whatever. We want to restrict who can access it based on those types of attributes. So ABAC in Databricks is actually pretty new. So again, definitely recommend going on to the documentation and stuff. But very cool feature. Again, as an ex-practitioner, I was kind of mad that we didn't have this when I was a user of Databricks. Let me drop this in chat. We're not going to actually do a quick demo on ABAC, but we're going to show RBAC real quick. All right, so what we're going to do, back in my Databricks workspace, we're going to go back to, I'm just going to close a couple of these tabs here. We're going to go to our old friend settings. So up here we have our account user, and I'm going to open up settings in a new tab. Within settings, this is not only where we can turn on dark mode, which hopefully most of y'all did, but we can also define things like our users and our user groups. Notice this can also integrate with whatever IAM protocol you use. So if you're on Okta or Microsoft or AWS, you can actually just have a single source of truth for your user groups and have your account admin permeate those down into your account. But for just a quick example here, let's create a couple of groups. I'm going to click on, so I did my settings, and then I went to identity and access, and then I'm going to manage next to groups, and oh, it automatically created some for me. So we see that we have analysts, data engineers, and retail admin. Great job, demo, for creating these groups. Let's add ourselves to the analyst group or data engineers, whichever, it doesn't matter. If you want to be a data engineer, you can add yourself to the data engineer group. So I'm going to go to analysts, and then I'm going to add member, and I'm going to add myself, hopefully. There we are. Hello, me. And I can add. Notice you can also add service principals and other types of government, I guess, things to these groups as well. So a very common use case would be like, maybe I want to have like a service principal and some people be able to interact with the dashboard. Let's all just add them to one group and have all those permissions be defined once in one location. So you can already see that with our analyst groups, we can define entitlements, permissions, and other types of things, and parent groups, all that good stuff. So again, all we've done so far, we've gone, this is also optional, depending on how much you want to follow along with the demo. But we went to settings, identity access, groups, either add yourself to the analysts or data engineers by clicking the group and adding members. What you should not do not add yourself to retail admin, because that'll defeat the purpose of the governance demo here. Once you've added yourself to one of the groups, let's pop back into our notebook workspace, and I'm going to open up Data Governance 02.1 UC Data Governance. And again, we should be able to connect to our serverless compute. And yes, we're actually going to run this notebook, hopefully. So let's see if we can run this and follow along. So with our governance on our security on our Lakehouse, what we want to do is we want to define protected tables, right? And define protected locations. I'm going to go to run clear all outputs and cross my fingers that this should hopefully work fine. So let's start running through these in order. I'm going to run through this first cell right here. Again, this is just a quick little setup cell. Don't worry about it. But what we actually want to do is, given some PII data, such as like the emails or the phone numbers or things, based on my group allocation, I want to restrict what I can access when I query those tables. This is typically known as a row-based filter or column masking. Column masking masks an entire column based on some condition, and a row filter will exclude or include specific rows, again, based on some governance filter. So let's make sure that everything is working. If I run this current catalog, it should hopefully give me a workspace. Yay. I love when things work. They always work. What am I saying? I'm just, we're just on some good luck today. So if we show the tables, we'll see all the different tables within our catalog. You'll also notice by default here, we're running in the SQL language. That's why I don't have to actually tell the cell to run SQL or not. So what I'm looking at is that we do not have a protected column table yet. So here, let's do some basic grants. We're going to grant select to the analyst groups on these 3 tables, and we're going to grant select and modify on everything to the data engineers. So again, this is already based on your user profile. If you're just a BI analyst, I don't want you dropping all of my hard worked Spark data declarative pipeline tables. I just want you to select whatever you need. But if you're a data engineer, then yeah, you should be able to manage everything. Like if I go on vacation, Artem should be able to come in and help save the day. Now let's add in some of these row and column level masks. So what we're doing here is we're defining a new table called churn users protected, just as a quick clone of the churn users table. Drop table if exists, or you could just comment that out. Basically, because the table doesn't exist yet, we don't have anything to drop. Boom. All right, so that should have worked. And now what we're going to do here is we're going to create a mask function. This is a column mask. This will mask an entire column. So what we're going to do here is if I am a retail admin, I'm going to bring back whatever the default column value is. Otherwise, I want to bring back these stars. So we're basically hiding the value of that column. That's why I told you not to add yourself to the retail admin group. We're going to add this simple mask function on these 4 columns: email, first name, last name, and address. Also, just fun fact, Sophia's like, what are you doing, Alexander? Get back into your notebooks. Databricks SQL mask function. There's some like built-in, basically, there's some basic functions that Databricks has built in already. So if you don't want to do those 4 stars, you can actually use this built-in mask function. And I think we also have an AI mask function as well, which is kind of fun. But notice in our case, we're just basically defining this mask as 4 stars. We also are adding a row filter. So this basically is saying, if I am a retail admin, I can see all rows. Otherwise, I only can see rows that contain US, so only in the US region. And we're going to add this row filter on the country filter. So if I run this cell, it should hopefully, when I do my select star, because I am an analyst and not a retail admin, I should hopefully see some stars. Oh, I love it. There's my stars for email, first and last name. And my country should only be USA, because that is my row filter that I have applied to. So very, very cool. So notice, again, just in this quick demo, we have applied a column filter and a row filter based on personas. As an exercise for the reader, if you go back and add yourself to the retail admin group, and then give it a minute so the permissions persist, and then maybe I can refresh the page. It takes a minute for the permissions to go through, so we'll see if this happens. But if I run this cell again, because I'm a retail admin, I should now see all of my columns and all of my rows without any of those masks or filters in place. Yeah, so the permissions haven't quite filtered through yet. They take a few minutes. But again, you can do that on your own time. So what we just demonstrated is using groups and basic column and row masking for RBAC principles, role-based access controls based on your role. You can interact with tables in different ways. And notice that a lot of this also translates to things like models and agents, right? Depending on your user group, if you are an analyst, you should not be able to utilize Claude Opus because it's super expensive. Or same thing with cluster policies. If I'm an analyst, I shouldn't be allowed to create a 16x 8-node giant GPU cluster that's going to charge me an arm and a leg, right? But if I'm an admin or a data engineer, then maybe I have different allocations based off of that role. So again, kind of the beauty with Databricks is that these RBAC permissions permeate into all data products created with Unity Catalog. We don't have time to do metric views, but this is going to be our semantic layer that we can then connect into things like Genie or other agents so they know our own business definitions. Your TLDR on metric views is going to be that how do you define the phrase total users? How do you define the phrase rolling average? Right? Is it always 7 days? Is it 30? It may depend on the team. It may depend on the user. It may depend on the executive. So with metric views, we try to translate those metrics into defined SQL semantics. So now if my CFO logs into my application and says, give me the rolling average of revenue for my Blockbuster stores, Genie and the agents should be able to look up in my semantic layer that rolling average means 7 days. Or even better, rolling average for someone in the executive RBAC group means 7 days. But maybe for like a manager on the floor of that Blockbuster, they want to see the last 30 days. So that's kind of how all this flexibility stuff starts being intertwined. All right, we're going to move ahead to machine learning, and then we'll end with our dashboarding. Y'all are doing so great. I'm so proud of you for keeping up. We still have like almost 200 of y'all, my bestest friends, still on the line. So that's awesome. All right, for the machine learning section, we've actually already done some of this within a lot of our pipelines. You may have noticed if we actually go back to the data ingestion, if I actually look at I'm going back to my Spark declarative pipeline, the SQL one. If I actually go look at the churn UDF down here, you'll see that we actually have a thing that is trying to do predictions. So most of y'all should have been asking, where did this come from? How did this exist? And if you go look at the 1.2 example here, you'll see that that's actually just the log stuff. We don't need to do that. This is like I talked about how if you fail expectations, we like log that off to a jail cell for you. That's kind of the same thing that this notebook walks through. But if we go to some of the definitions I'm going to the Python one. Again, you don't have to follow along with this. I just want to quickly show that the inferencing and making the predictions. Let me see, maybe it's in this one. Yeah, there you go. We're creating this table churn prediction, which is going to be the inference of running our model features through kind of the model. So I want to go back and say, where did this model come from? How do we build it? How do we train it? And then hopefully we can see is now we can start handing off data products, right? Once our machine learning engineer creates the model and trains the model, they can host it in a registry. And now my data engineer can then utilize that model to make the inferences as part of the data pipeline. And that data engineer doesn't need to really know the algorithm, your log loss versus your R squared, right? They don't have to know any of that. They just need to know where the model exists and then how to consume it within the data pipeline. Hold on, let me reconnect my headphones here. Cool, we're back. Cool, so let's go talk about how this model was created here. If we actually go back and look at now section 4, I'm going to open up this first notebook, this AutoML churn. So with Databricks, there's multiple ways to do machine learning. And again, we've talked a lot about bringing your data to your models, bringing your models to your data, doing everything in one centralized place. Data science within Databricks, we feel, is its own use case. You don't even need to do the data engineering in Databricks, but if you want to build models at scale, we definitely recommend Databricks as the place to do that. So there's two reasons why. First, how do you get machine learning to work at scale? And that scale can be simply the size of the data that you're training on. It can be the streaming integrations of how quickly you need to be making these inferences. And it can even be how many models you have. Like I have customers that have hundreds of models, which is kind of crazy. Some going into the thousands, right? Like how do you start organizing all of that work, right? So the first step is the size of the data. How do you train models on this data sets? At Databricks and Spark, in the open source Spark, there's actually a library called Spark ML or Spark ML lib. This actually got a big revamp over the last couple of years, And now it's even better. So essentially what this allows you to do is, using pretty familiar syntax, you're able to use a distributed cluster or even serverless GPUs to start training on large, massive amounts of data. So I have customers training models on terabytes and petabytes of distributed data using our Spark distributed engine. So this is great for at least distributed training, especially as we move into things like computer vision, your neural network applications, your PyTorch applications, being able to run those on GPUs, distributed GPUs, your fine tuning. That scale is really difficult to do, and Databricks makes it easy. Besides Spark MLlib, it's also really cheap to just do regular machine learning on Databricks. You can spin up a single node, pretty small cluster, and you can train your LGBM or XGBoost model in just a couple of seconds, right? So the second problem that Databricks solves, and why you should do your machine learning even on small models there, is the MLOps problem. So MLOps, of course, stands for machine learning operations. And again, it's kind of where traditional ML systems fail. When I worked as a practitioner, we had people training models on their local machine. We had people training their models on SageMaker. We had people training their models in Databricks and in random places. And when you have multiple people training models in different places, it makes it really difficult to centralize, reproduce, and observe and be transparent about those models, right? Again, to me, let's say I leave the organization and Artem's like, what is this random forest that Alexander made? Like, what the heck is this? I don't even know what it does. I don't even know what it was trained on. I can't reproduce it. He hasn't logged the metrics anywhere. It's really difficult when you have all these disparate systems. So with Databricks, we integrate with an open source software called MLflow, which again, we are an active contributor to. And with MLflow, we're able to track the whole life cycle of your model. So again, this holds true for regular machine learning. And again, you can actually use MLflow in free edition, which maybe is what we're about to show. We can walk through different runs and experiments, training different PyTorch algorithms here, looking at different training metrics, and actually caching off the training data set. We can orchestrate models in part of your data pipeline, as we've shown. And of course, you can serve models via APIs within a Databricks as well. Finally, with MLflow, this MLflow 3, which was released, I think, last year, we now integrate with generative AI applications. So same idea, right? Whenever you change a system prompt, that's like the same idea as changing a hyperparameter, right? If I have a random forest that's built with 100 trees, and then I train another random forest with 200 trees, those are two separate runs, two separate experiments that I need to compare against each other. Same thing with an LLM agent. If I change the system prompt by adding in some extra details, I've created a new agent, and I should be able to evaluate those different models against each other, right? So MLflow 3 kind of takes that idea that, hey, tuning an LLM is pretty similar to tuning a traditional model, and unifies and expands upon that to kind of really meet you where you are in your agentic development. So whether it's evaluating agents, monitoring agents in production, experimenting with different types of prompting or RAG applications, you can do all of that within MLflow. So finally, with what we wanted to show in this experiment here, Databricks has some pretty good AutoML capabilities. Again, what that means is you set the data, you set the algorithms you want it to check, and you just let it do its thing, where it goes off and trains a whole bunch of models and finds the best one for you. So we could run this notebook, but it takes about 10 minutes to run all the way through. So again, if you want to run this now, it should work. Connect to the cluster and then run all the way through. I'm not going to run it just for the sake of time here, but we will scroll through it. So what I wanted to show is, as we start running this notebook, again, this is a pretty procedural notebook. We're just writing our own code to be able to create this model. Notice that we can look at the different distributions and pair plots using Seaborn, do some EDA. We're going to stick with Spark. So we're going to use the Pandas API. If you've never heard of the Pandas API, it's very cool. It used to be known as koalas, which I was a huge fan of because I mean, koalas are really cute and cuddly. But essentially, this allows you to use Pandas syntax on a Spark data frame. Again, goes back to that 10,000-foot idea that Spark as a syntax is kind of messy and kind of different than what we're used to. So being able to utilize Pandas syntax and SQL syntax makes it a whole lot easier to interact with Spark systems. We're selecting the data that we want. We can write this data to a feature store. Again, a feature store is a really low latency lookup, which is really useful for live inferencing. Let's say that you've created some feature or combination of features, and when you make an inference, you don't want to necessarily recalculate how those features are engineered. We can save those off to a low latency feature store. Our Databricks feature store actually integrates with our Postgres offering known as Lakebase, which is really cool. And depending on how into your press releases you are, you may have seen that we acquired a company called Tecton a couple months ago, which is again, a feature store that will hopefully, it's pretty cool. I have some customers using Tecton right now, but it allows you to kind of serve features back to large language models with really low latency as well. So as we start expanding agentic development, the world of agentic development and traditional machine learning development are really coinciding. I think soon enough we'll have like a grid search for agents where it just tries out a bunch of system prompts and sees which one's the best for you. I probably wouldn't be surprised if something like that already exists. But anyway, we're creating a feature store here to contain the training data for our model. Again, feature stores are also good for that as like a cache to show you what your model was actually trained on. And then here comes the meat of the section here. I'm actually using an AutoML library. So sure, if I knew, I mean, I love my light GBM models, so I probably could have just done this with a light GBM model, but I prefer the AutoML runs because again, behind the scenes, it's gonna go through a whole bunch of hyperparameters, try other algorithms such as through scikit-learn or elsewhere, and come back with the best model. So this should have run. It's hopefully should have run for us as we installed the lab at the beginning of the lecture. So let's actually go see what happened. We can see that this should have run for hopefully about 10 minutes or so. We can see it's actually not a bad model. We have like a 861 F1 score, 792 rock awk. Don't get hung up on the metrics here. Note that typically higher is better for rock and F1 score, and lower is better for log loss. But we can see that this actually made an experiment somewhere, and we should be able to go find it. So let's actually see what happened. In a new tab, I'm going to go all the way down under my AI ML section, and I'm going to open up experiments in a new tab. Oh my God, I love it when things actually work. And if I look over here, we should hopefully see that, yeah, I've been playing around in free edition for a couple of months, but we should hopefully have this AutoML experiment that ran today. And it looks like we did. Again, if you run this notebook yourself, this will kick off a new experiment. So the AutoML grid search will run for another 10 minutes. That's kind of why I'm not running it, because it was already run for me. But within my experiment, we can see that it ran this light GBM model. We should be able to open some of the columns. We can add in things like all the metrics that I wanted to log and record. And we can see a lot of things like all the different precision, recall on my training, validation, and test set. And if you're someone like me who actually likes doing machine learning stuff, you may want to see all right, what did this actually look like? What happened kind of with the code? So AutoML generates a notebook for us. So that's what this 04.2 is. If we open up this is what the notebook automatically creates. So we can see that it's running light GBM. It's loading up on our experiment. It's grabbing the data, and then it should be able to run a distributed hyperparameter search. So I think it uses hyperopt to do it. But I think we're starting to move away from that, which I'll talk about in a second. Blah, blah, blah. Trying to find, you can see it's using MLflow to log everything, including our metrics and our experiments. And I wanted to see if it actually did run hyperopt, but it may not have. Oh yeah, configure the hyperparameter search space. Pretty cool. So I found the best model for me already. I think that's why it went so quick. We just had the one trial. And yeah, here it's using hyperopt to do our distributed hyperparameter tuning. That's another use case for machine learning at scale is hyperparameter tuning. Again, if you're just running on a single computer or your own laptop or a single node machine, doing hyperparameter tuning can take a long time. So being able to distribute, parallelize all of those searches makes it a lot easier to run. And to me, this is again, I'm nerding out again. This is beautiful, this little graph here. I've had to code this out from scratch multiple times to make this beautiful pipeline. And it's nice that AutoML can just kind of slap it for us. Cool. Let's see. We can even look at our Shapley values, all that good stuff as well. If you want to do something cool, I'm going to go off book here. Sophia's face palming again. I'm going to go a little bit off book to do something. So let's see if this works. It worked for me last week when I was doing an enablement session. This is like brand new and free edition. So let's see if this works. So all I'm going to do here is let's actually navigate to our Databricks assistant. So that's the little pink little star icon here at the top. I'm nervous. My heart's racing. All right, let's see if this works. For my little agent mode, what I'm going to do is add context, and we're going to give it a table, and I'm going to give it the churn features table. And notice that we have this option now to switch it from agent, chat, or edit. So this is kind of like Cursor, if you've used Cursor or something like that. Before, our Databricks assistant used to be only chat. So you could only like ask it questions and things. But now it can actually write code for us. So I'm going to click on agent, and I'm going to say, yo, and I'll drop this prompt, I guess, in the chat. Please make a new, let's actually make a new notebook for it because I don't want to make it do too much work. So in my workspace here, under my 04, I'm going to make a new notebook. So we have a new Scratch notebook here. Please write code to train a model to predict churn for me. And we'll see if it works. Maybe I shouldn't say yo, but whatever. Super professional in our workshop today. If you want, there's my prompt that I gave it in the Zoom chat. So notice that the key thing here is you have to give it the context of the table that you're working with. And then you just go off, get lunch, do the normal thing where, I don't know if you've seen that like XKCD meme of model is training. This is like the new thing. It's, yeah, this one. Yeah, it's like my code's compiling, my model's training. The new one now for Gen AI is my agent is doing all the work for me. So if we pop back here, it's given me some stuff. We can allow it to work. And it's going to take a while. It's like our agent in Databricks, it's very, it likes asking for permissions and it likes like double checking with you. So it's very conservative in what it can do. It's not like Cursor sometimes, which like does whatever it wants and you come back and it's done like some crazy nonsense. So our agent is in preview right now. So feel free to give it a try on your own time. But if things work, I think it has. We have loaded up the data set. It's trying to do some data exploration with wide data, which is a pretty cool library for data exploration. And hopefully it starts building a model pretty quickly here. And there's ways to alter the permissions to have it like just do whatever. You can just have it like auto approve to run code and do everything you want. But yeah, no, it's pretty cool. And again, it gives you the plan of like what it's going to do. So we're exploring the data, pre-processing, clean the data, split the data, train the model, and evaluate and log the model. So hopefully this doesn't take too long. Sorry, Slack, I can't update you. The only thing with, no, this should be fine. I think it'll go. I'm gonna have to give it a hard stop though in like 5 minutes so I can continue to do some other things in the lab. And all it's taking so long is like installing some of the specific libraries that it wants to get white data to work. Ooh, there it goes. Now it's actually running. Ooh, I love it. I don't know why I was always like, oh man, it's great not to have to write code anymore. That's the thing though. Don't trust your Gen AI agents too much. I'm always kind of pessimistic about the agents as well. It kind of goes back to like if you don't understand the code that's being created or the code that's running, how are you going to support it, right? And I know there's some like AI enthusiasts in the chat that's going to be like, oh, we'll just have another agent that manages and debugs all my code for me. Like, come on, you gotta have a little bit of human in the loop in there somewhere. Otherwise, who knows what kind of ends up happening. So this should have worked. It should hopefully generate this white data report for data exploration. And then actually building the model should be pretty quick. Yeah, there it goes. So we're doing the same type of thing. We're loading up our transformer, our different pipelines. And yep, I allow you to run this code. And we're going to do our preprocessor. And yeah, it's going to be mad that it's missing libraries and things. So it's going to go back and reload things. Install. Yes, you can install the library. One of the other things on this is running on serverless. If you have a classic compute, oh, there it goes. Then you can just spin up a compute with the machine learning Databricks runtime, and all these libs will already be installed for you. And also, if your agent generates a little bit different code, that's the thing with Gen AI, right? There's no guarantee that our agent will generate the same text and content and columns and things. If you ask the same question to ChatGPT, it's going to give you slightly differently worded answers. So same kind of idea here. Your code may look a little bit different than mine. But I wanted to demonstrate the capabilities of Databricks Assistant as an agent to start doing data science work. So we call this the data science agent. And for my data engineers on the line, yeah, it's also pretty good at doing those Spark declarative pipelines and things as well for you. All right, so we've done our pre-processing. Oh, here we go. We're doing our train test split. It's already done it. And we're training a little random forest. Sure, why not? We're using MLflow to log everything. We did it. We loaded an experiment. Oh my God, I can't believe this worked. I can't believe it. All our Databricks products are so good. Logged a run to the experiment. We got our rock and our accuracy. And here we go. And here's what the test data looks like. Oh my God, your churn model is now fully trained. Great. I could say thank you, which I probably should. Be polite to our AI systems. Cool. And if we go back here, we actually have this little icon on the right, which is like a link to the experiments, which is pretty cool. So we can actually go check out the experiments, and we should see our new experiment here, which is, yeah, I forgot to label and name my notebook, so it named it pretty poorly. But here it is, Sincere Stork 851. It should be in my little random forest. And what's interesting is that this model should be worse than the other one we created. Someone remember 786. Oh, here it is. Here's the other one we created with the hyperparameter tuning. And we should have, that was what, test accuracy? What's test awk? 076. If I go down to my test awk score, yeah, so my hyperparameter AutoML tuned model did outperform the one that my agent made. But again, the point that I wanted to demonstrate is that the Databricks Assistant as an agent can really accelerate your modeling and machine learning workloads, as well as standardizing all of your code for you. So I'm going to call this Databricks agent demo, which I probably should have named the notebook before I ran it all. Very cool. A couple more things to show on the machine learning side, and then we will kind of end our time here with the dashboarding and Genie tools. All right, so once we have our experiments, we have our runs, right? We've talked a lot about MLOps and being transparent with our models that we create. So again, the idea is that if Artem comes back and is like, Booth sucks at making these models, he used a random forest and the agent, I'm going to be hands-on and I'm going to create a real model. He can actually log another run in the same experiment. And what that does, it allows you to compare multiple different models against each other. You won't have this in yours, but if I go check like one of mine well, I guess this is all I got here right now. I'm gonna say, depending on kind of the different models that ran, you may be able to see some of the different runs against each other and how they did. So pretty cool to be able to compare those runs. But not only do we want to use MLflow and Databricks to track and reproduce different training exercises, we want to make sure that we have a transparent and visible allocation of which models are we deploying into production and how are they being served. So not only can we play around with experiments, but let's actually pop down to models. So when I click on the models here, sure, it gives me a bunch of system models. These are basically the large language models that Databricks gives you to play with for free. But we also see the models that I am defining from my experiment. So the idea here is I'm going to go into models. You should see one called DB Demos Customer Churn. And if you click on that, it should actually take you to the model within Unity Catalog, which is kind of cool. And you can see that we have two different versions of our model here. You may only have one. It depends on kind of what background tasks have been triggered. But I'm going to click on the most recent version, version 2. And you'll see that not only do I have all my metrics linked, all my hyperparameters linked, all my pipelines linked, but we can actually go directly to the run that created it, right? I can actually see about this model version at the very bottom. What is the model with its artifacts, like its pickles and requirements and JSONs and all that good stuff. Not only can we see the model artifacts, which again should be stored in your own S3 bucket. So there's a lot of interop if you want to deploy this somewhere else besides Databricks. I'll leave it as an exercise to Google SageMaker deployment from Databricks registry. But we have our model artifacts here. And we can also go to the run. So I have this source run of LightGBM. And this is the run that was saved in my experiment, right? So we showed this experiment earlier. I have the run. I have all my metrics here. So what we now have is a direct link. I can go see the model that was logged within Unity Catalog. I know exactly what model, run, and experiment created that model. I have transparency into the data set that created the model. I have transparency into the metrics of that model. And now it becomes really easy. If Artem thinks that I made a bad model, then beat it. Come on, I challenge you, Artem. Make a challenger model. Do your own training, save it off as a run, and compare the metrics. And if it really is better than mine, then we can create a new version of the model within Unity Catalog. Here's my little model. We can create a version 3. And if we really want to go hardcore with it, I can alias Artem's model as a challenger. And now we can serve both models in kind of an A/B test. Your head exploding right now. Mine is. We can have 50-50 traffic to both versions. And if in live inferencing and live predictions, Artem's is acting better, then we can change that allocation. So I'll show you how to quickly do that. But again, I really wanted to showcase the transparency, the linkage, how everything's connected from your data to the model. And if you really want to go nuts, I was going to say, depending on our table, if I go to the churn prediction table and go to my lineage, I should also be able to see some of these models in the lineage, but I may not be able to. I may have to do something different to actually showcase that. But we can see how the models actually interact with the different data sets within our environment. The last thing I wanted to show on the machine learning side, if we go down to serving, and again, maybe the astute student here, you saw on the version, if you scroll down far enough, you can see that this model was deployed to an API endpoint, an active serving endpoint. Let's actually go ahead and take a look at that. And again, hopefully all your background tasks have done and actually executed this. But we can see that we have, of course, all of our LLMs that we demoed in the playground already, but we have our DB demos churn model. And we can see that it is serving version 2. It's scaled down to 0, so we're not actually burning any costs right now. And if I really wanted to, we can edit this endpoint. And you can notice that 100% of the traffic is going to version 2. But we can add another one. I can add version 1 of this. I can add version 1 and I can allocate the traffic as 50-50. Which is pretty slick, right? So that's what I was saying. Now you can start doing your A/B testing. And by default, if we look at some of these advanced configurations, we can serve inference tables. We can log all the inferences to Unity Catalog, to our Delta tables. And now our machine learning engineer can come back in a week and figure out which one actually is performing the best. And then they can promote that challenger model to production, redeploy our serving endpoint so 100% of the traffic goes to Artem's version. And now our data engineer doesn't even have to do anything different because let's tie this all back. Oh my God, coming full circle. Sorry, I'm nerding out again. And if we go all the way back to our churn model, our little pipeline thing that we did. Let me go. I'm gonna show you the Python one because I know it exists there. If I pop into my little gold table down here, you're going to notice that we create this churn prediction model by going to the prod alias of our DV demos customer churn. So my data engineer doesn't have to do anything. Once we've proven as a machine learning engineer that Artem's version is better, right? We've aliased it as prod as opposed to challenger, right? We've updated the alias to version 3. That's Artem's model as prod. It'll automatically be picked up back in my data pipeline, which is pretty cool, right? Again, we're trying to limit the friction between our data engineers and our ML engineers. Again, coming from a practitioner background, whenever I created a new model, or someone created a new model, it was always a pain in the butt to like redeploy it, reserve it, update the features and all that good stuff. But Databricks would hopefully make that a lot seamless, a lot more seamless for you. All right, big ideas on what we've covered in the last 45 minutes. We're golden on time. I am proud of myself. A couple of big things we've shown on the machine learning portion of the lab. First, we introduced the idea of machine learning at scale and the pitfalls that you run into. So just to summarize, machine learning at scale can typically fail when you need more compute or data, right? Training a model at scale. How do you train on 5 petabytes of data, right? You have to have distributed computing and distributed data to do that. Spark ML can help solve that problem. Same thing with hyperparameter tuning. You want to tune hyperparameters of a PyTorch model or a neural network, or you want to try out a whole bunch of different system prompts on your fine-tuned large language model. You again need GPUs, you need serverless to be able to do that. And again, quick thing on that. Again, this is a pretty cool. I've been using serverless GPUs on Databricks for the last couple of weeks, which is very cool. Again, it's in beta, and if you want to pay for it, like it's there. Again, you can't do it in free edition by definition, obviously. But if you're in a corporate account, definitely give our serverless GPUs a try. It really speeds up kind of that model training for you. So we've also talked about scale of number of models, right? Number of models, number of model versions, right? You can have hundreds of models, and each of those models could have dozens of versions, right? Or again, I have one customer who's built out an agent that they've iterated it 80 times. It's got 80 different versions with 80 different like system prompts and vector stores and all that good stuff. How do you start organizing that at scale? How do you make that observable and transparent? And how do you tie that back into overall governance for your entire data architecture? So that was the last bit on scale that we talked about. By utilizing MLflow, our open source tool for machine learning operations, you can organize your experiments, organize your runs, and organize your library of deployed models. And then finally, we talked about model serving, which is where we can serve these models on endpoints, challenge them with A/B testing, and actually really make data-driven decisions on what is the best model. And actually creating the models, we demoed in our code what it would look like to use AutoML. And then just for grins, we used the Databricks data science assistant agent thingamajig to spin up a new notebook for us to do a quick kind of model training. And then we even compared the random forest that the data science agent created versus the light GBM model from our AutoML solution. And again, proved that our AutoML hyperparameter tuned model does do better, which again is probably to be expected, right? So very cool. Hopefully, if you have some spare time and you're really interested in some of the machine learning capabilities on Databricks, go read our MLOps documentation. There's a lot of really good information on how do we integrate MLOps and LLM ops, right? Large language model operations, both with your AWS services and then just as a philosophy as you start kind of organizing your agents and classical models at scale. Let me plop this in chat. All right, let's take a breath. I got 11:31, so we're well on our way here. Starting the prompt with yo. No, that's not professional. I should always say, my dearest data science Databricks assistant agent, I would love for you to create a new model for me. I was going to give you a break here, but I'm not. Maybe 60 seconds. Stand up, go jump, shake it off. We got 30 minutes to the finish line here, and y'all are killing it. This last bit's easy. No code. We're doing dashboarding and Genie. Piece of cake. So 60 seconds. We're back at 1:33 on my clock. Let me check the Q&A. Still got 156 of y'all. I really appreciate your time and sticking around. If anyone has questions on any of the data science ML stuff, now's the time to ask it.
Alexander, what we will cover next, just to tease dear audience.
What are we covering next?
Yeah.
Yeah, so next we're going to cover some of our AI BI interactions. So how can we start visualizing some of these engineering and machine learning pipelines up to non-technical users, and also introducing text to SQL, our Genie space. If everything I've walked through has been very technical and kind of going half over your head, then this last little bit is just for you. Or as I always used to call it, it's like, it's all well and good to do all this awesome code and do all this data engineering and machine learning engineering. But if you remember back to 2.5 hours ago, I was like, the only purpose of this is to make decisions better, right? Make actionable insights, actually make efficient decisions. So we have to somehow bring a lot of this back to those decision makers, right? Those stakeholders who are going to be looking at the information. So with Databricks, we have some built-in BI capabilities. And of course, with the intelligence engine, we can wrap AI and text to SQL, interact with you in natural language, in multiple languages, Spanish, Japanese, whatever. And we can use that to then query our tables and bring back that information to you.
But to cover all this, we have only 17 minutes left.
No, you just wanted, I was going to bleed into your time, but now it's all right. Yeah, so let's get started. I'm going to go into some of this dashboarding stuff now. All right, so let's actually get back in our notebook. I got one question. Does Databricks allow data analysts and other related certificate concessions on the attendee? I'll let some of the TAs answer that. Basically, we have different certifications you can sign up for. And we typically do occasionally like hackathon. I think there's a free edition hackathon going on right now, and other kind of certification opportunities where you can get like half price discounts and stuff off an exam. But no, all you get for showing up here, you can take a screenshot of me, tag me on LinkedIn, and I'll give you an update. And that's all you get, unfortunately. But whatever you need, we got you. All right, let's pivot back to some AI warehousing things. So if we go back into, I'm going to go into my notebooks. Let me just close all these other ones. And I'm going to open up 03 AI BI data warehousing. And we'll notice that we have a quick notebook of what our AI BI tool looks like, right? So now we're coming back to our BI analyst. Again, the big idea here is that traditional warehouses can't interact with the variety of data products that we're creating these days. Whether it's models, whether it's unstructured and semi-structured data sets, whether it's vector searches for your RAG applications, whether it's interacting with your custom agents. So Databricks has spent a lot of effort over the last couple of years investing in reporting and application services. So we serve things like Databricks apps, where you can create lightweight data apps built with something like React or Dash or Node. We also have some BI dashboarding tools. And then, of course, our text to SQL capabilities as well. Again, all of this is secured with the Unity catalog. So if you think back to our row filter, for example, I know Artem is the one interacting with my Databricks app or my dashboard. So when he refreshes the dashboard, I can pass his user profile and group to the query, and it only brings back the data that he's allowed to see, maybe only the US or maybe the masked PII data. So again, that's the big idea. How do you start combining some of the consumption of these data products with the governance strategy that expands across your entire Lakehouse architecture? Last thing to note on this is how do we actually execute SQL? We have a special compute called SQL warehousing. SQL warehouses, which is really, really quick, really performant, and really cheap, especially at scale. As you start querying larger and larger data sets, it becomes even more cheaper and cost efficient to do it on Databricks. There's a lot of benchmarking out there on Databricks SQL warehouses. But again, what I want to get across to you is Databricks SQL is not going to be any slower than some of the other warehouses that are on the market today. So let's go look at our churn dashboard. So again, we actually spun one of these up for us earlier. To open up your dashboard, we can just link it here, or I can open up dashboards in a new tab. Again, I did that on the right. And we should hopefully see our DB demos, and we have a couple of different dashboards that it's spun up for us. Again, we actually have one that it created on our Spark data pipeline, where it gives us a quick dashboard consumption of our engineering jobs and workloads. And again, just to deviate a little bit, this is actually a really good use case for Databricks dashboards and Databricks BI tools. Having a transparent and visualized way to evaluate your jobs, evaluate your data quality, evaluate your pipelines. And this, of course, you can trigger and send SQL alerts to PagerDuty, Slack, or Teams to whoever you want to wake up at 2 in the morning when your job fails or when your job alerts with some invalid data. So as I'm looking at my Spark data pipeline from earlier in the day, we'll notice that we ingested 3.3 million rows. We have some key metrics up here at the top. We can see kind of the lines of ingestions and failures. We have some quality statistics about which rows are we dropping, and we have some ingestion errors versus expectations. So again, that's use case number one, right? Utilize BI to help provide visibility, monitoring, and auditing of your pipelines, your engineering pipelines, machine learning pipelines, agentic inferences, whatever. The other use case for our BI tool is also to create dashboards for external consumption. So I'm going to open up the churn prediction dashboard. And I got a couple things I'll actually show you behind the scenes of this once it actually loads. But we hopefully should be visualizing the outputs of our machine learning model that's predicting the probability of churn for our customers, as well as things like the features and metadata of those customers. So there's a couple really cool things here. At the top, we just have some quick high-level metrics. We have our donut charts and bar charts, and just a leaderboard table of users and whether or not they're going to churn or not. So how do we create this? Well, first, it all comes back down to the data, right? At the top left of my dashboard, if I click on data, you're going to see that we have all of these different data sets, which are essentially just queries. And again, for best performance, I would recommend actually having these queries be saved off as materialized views in your pipeline. And that way, when we refresh our dashboard, all they're doing is a select star against that view. That same paradigm holds true if you're using Looker, Tableau, AWS QuickSight. Yeah, for my AWS people on the line. Whatever you're doing, right? You want to actually try and limit the amount of compute and complexity in the query execution. But Databricks, again, is optimized for these queries at scale, especially on data that's in Delta or Iceberg within Databricks. So we have all these outputs of these queries, saving them off as individual data sets. And you can see at the bottom here what they look like, the different countries, the churns, the number of customers, etc. And you can see to create one of these data sets, we can just create from a SQL query or create from a view or a metric view for semantics and things like that. But if I go back to my dashboard, from here, we can create a new widget. And I was going to see if I could add the assistant because I'm lazy. Let's see what I want. I think I had to opt into it. Yeah, we don't have Genie in there yet. but I think we could. I'll do that later. There's ways to also use some of our agentic AI to like build our dashboard for us. But yeah, we can add new widgets and things in here. To do that, we can just, let's see, where am I going? I want to, aha, add a visualization. Let's slap a visualization down in here, and that's where we can go. Ask the assistant to create a chart. Great, because I'm lazy and we don't want to actually do all the work to create things. Yes, 150. All right, 10 minutes. Cool. Let's say create a bar chart of most churn by country. And it does not like country. I should have given it the context of which one. Let's just pick one of the default ones. Monthly revenue risk counter. Great. And if we're curious, you can actually see kind of what this is actually kind of doing behind the scenes, which is pretty cool. So again, there's ways to build AI into your dashboard designs. Once you have your dashboard ready, you can publish it and we can share it with whatever we want. We can share it with each view of a dashboard can use their own permissions. This is what I would recommend. This would apply the row filter and the column masking based on the user who's interacting with the dashboard. And then once we've published the dashboard, we actually see it in like its own new tab. And as we start moving into trying to help less technical people interact with Databricks, what's the link, Artem, for Databricks 1? Is it just
You can just use this feature on the top. So you have these 9 little points. And next to your, go back to the Workspace.
okay.
So go to the right-hand corner. Do you see your little A? Yeah, here. Click on it. Click on 9 points. Click on 9 points. Yeah,
Aha, there you go.
switch. Yeah,
Love
and
it.
just
All right.
to retrieve the link is just 1 on the URL. But what is incoming is that we will have just one unified URL across all the workspaces. And this is named as Databricks 1 account level. It will be available in December, January.
Yep. So the idea for Databricks 1 is, again, if I'm an executive or an executive stakeholder, I don't want to be interacting with all the crazy data engineering and machine learning MLOps stuff in Databricks. I just want to find my dashboard and take a look at it, right? So Databricks 1 provides a streamlined interface for those kind of business consumers. So here's one I made on baseball a little while ago. But let's go find one of my recent dashboards here, this retail churn prediction. And just by kind of navigating here, I can find dashboards and Genie spaces really quickly and efficiently. So my last 5 minutes, I wanted to quickly show what a Genie space looks like for us. So you may have seen Genie spaces here a few times. Every time we've been interacting with the assistant, it's kind of like running kind of those Genie spaces. So if I, on my left-hand pane, go down to Genie, or if I had gone into my notebook and clicked on AI BI Genie, what we can do here is we can create a Genie space to interact with natural language to query on top of our data sets. So it actually didn't create one for me, so let's go ahead and do that. So feel free to either to follow along live here. On the left-hand tool pane, I'm going to go down to Genie under SQL. And with my Genie space, we're going to create a new Genie space. And in my new Genie space, let's query against the churn prediction table. I'll also give it the churn feature table as well. And we'll hit create. So I'm giving it access to my gold level tables, right? That's kind of the idea. Within our Genie space, we can give it instructions. So this is also some of the semantic layer. We can also connect this to our metric views if we want to bring in our example business semantics into this Genie space itself. And we can also give it some example sample questions. So let's just give it the first query, just explain the data sets. So it should hopefully give me some information about these tables. Like, notice how quick this was, right? We just threw a couple tables into this agent, and it gives us a quick description of what they are. And we can even keep going with the conversation. What are the key metrics available in the churn prediction table? And then you can see that it's actually doing thinking. We call this like deep logic now. It's doing the deep logic on there. And again, all we're doing is querying the metadata, querying the comments on the semantic level of the tables. And the last thing that we can add here, let me see if I can find one of the queries that I wanted me to do. What was the daily revenue from, I don't think we have daily revenue, but what is the average order count for users at risk of churn? Great question. So this is actually going to take this natural language, translate it into SQL, execute the SQL behind the scenes, and then bring back the results. So I can actually show the code here, and it's telling me, hey, this is the query that it created. And we can actually expand upon it with secondary questions. So I'm going to do a secondary question, which is I want the breakdown by region. And this will be my last question that I ask it, and then we'll see if it works. Cool. So there we were able to break it down by region. And now it's already knew the context that I wanted the average order count for users at risk of churn. And it just added to this query the fact that I wanted it by region. It also gave me a quick bar chart here, which is very cool. To close this out, if we change this to be like churn Genie space, and I go back to my dashboard, whoa, that was a whole 5 minutes ago. Let's go back to the unpublished version of it. Let me go find my dashboard again. Boop, boop, boop. Notice that if I went back to my edit and draft mode, if I went back to my settings, we should be able to toggle on Genie. So enable Genie, and we can link to an existing Genie space. And I can go find my Genie space, and we can either just grab the room ID, or we can grab the entire URL. I'm just going to grab the entire URL, slap it in there, and see if it is able to find it. Maybe I should have just done the ID. Let me just try to do the ID here. And hit enter. And if I close that out and then refresh. What am I missing anything here, Artem? I thought that was a way to get that Genie integrated.
Yeah, you need to publish it. Once you publish
publish
you
it
have
again.
check. Yeah.
Tell them, got Genie enabled. There you go. Great. And we won't enable. Let's view the published dashboard. And again, this could be linked through Databricks 1 as well. And perfect. There's my little Genie button down here. And again, I can give it the that original question that I asked about. What is the average order count for users at risk? It's my last hurrah, Sophia. Break down by region. Hopefully don't give it too many typos. And let's see if it works. So now we have the natural language interface within the dashboard for our users. And boom, there it is. And we have kind of the step-by-step and the kind of ways to visualizations and things inside of our dashboard. So AI with your BI, voila, AI BI dashboards. Last thing just to note on Genie, Genie actually can exist as its own MCP server or as its own API. So let me actually pull that up. So what this means is it's really easy to connect a Genie space to a Slack or a Teams or something. So we can see like here is a Genie space that you can just add in. So I've had lots of customers now that they actually don't even interact with Databricks. They use Slack or Teams, open up a channel or a bot, write a question. It queries that against the Genie space and then brings back the visualization and the table, which is pretty cool and efficient. 11:50 on the dot. I'm tired. This was fun. Hopefully you found this exciting, or at least got you thinking about different ways that your organization is working with data and big data at scale. I think we'll stick around here for a few minutes. If anyone has questions in the Q&A, Sophia's already put up the poll. If you can answer that, that'll be great. Thanks for sticking around. I appreciate your time, and hopefully I'll see you on another workshop sometime in the future.
Thanks so much, Alex. And yes, as he mentioned, the poll is live. Please do take a moment to answer that. We truly do leverage all of the learnings to improve time over time. So appreciate all of your candor. Please look out for an email from us tomorrow with all of the resources, recordings, slides, and some of the links that Alex shared. And some of our other subject matter experts posted into the chat. Looks like some questions are still coming through, so I'm going to go back on mute and let the team take it away. Feel free to stay on for an extra few minutes.
Yep, someone asked about how to shut down any of the resources for the lab. If you're on free edition, then there's no charge to you, right? There's no credit card, so you don't need to shut anything down. Just charge it back to Databricks. What actually Databricks is doing behind the scenes, since everything is run on serverless, serverless has a timeout of like 10 minutes. So Databricks free edition will automatically turn off the serverless compute that you used during the sessions. I think there's only one other thing I wanted to share, which is that I think if you go back to Databricks events, you can actually see, I think we have a couple more trainings coming up at the end of for the end of the year. I think this is the one today, but I think there's, building an AI systems one tomorrow. And I think there's a couple in December as well. Yeah, Databricks SQL in action on December 10th. That'll be more on the AI BI stuff that I only had like 30 minutes to cover at the end here. And I think that'll take us to the end of the year. So there's only a couple other options. Hopefully everyone enjoys the time off and the holiday season coming up. And yeah, reach out to Databricks, your account team, if you have one, or just anyone that you know on Databricks. And we're happy to kind of start bringing some more of these use cases to reality for your organization. For the 122 of you still on, workshop's over. Enjoy your lunch. Have a great afternoon. What else we got on the Q&A? Future events? Sure, I'll drop that in. Let me see how I can add the filter. There's like a filter to just change it to trainings. Webinar and workshop, I think. Yeah, maybe webinar, maybe a workshop. Yeah, workshop. That's the one how we found the things. So there's only 2 left for the end of the year. But there'll be plenty in the new year as well. Let's see.
We have specific product workshops that are hosted twice per half. So we'll kick back up with a new schedule, starting with the AI deep dive in January. And then all of those programs will be listed on the events page.
There was a question in Q&A about best practices for CI/CD and data pipelines. I do not have time to go in detail, but I'm going to drop in our documentation on Databricks asset bundles for all you CI/CD enthusiasts out there. This is the best way to use things like Terraform and infrastructure as code to configure both your pipelines and your Databricks workspaces. I've seen customers, again, not even use the Databricks UI, but use things like VS Code and PyCharm and things using Databricks Connect, which I'll also drop in chat, to basically connect using the service to your like cloud ecosystem. And then you can couple this with dabs and Terraform. Sorry, I have a typo 4 there. Let me see if I can delete that. Yeah. To help make things a little bit more sustainable and reusable. I have people asking me all the time for like unit tests and integration tests for their data pipelines and things. So there's ways to do that. But again, I also tell my customers who ask that like, hey, like declarative pipelines is supposed to help abstract some of that away, right? But yeah, I think Alex Odd, he can find him on YouTube and stuff. He's a Databricks employee as well. He's very big into DevOps and CI/CD. How long can I access the recording? The recording will be sent 24 hours, I think, after this.
Yep,
and you can
it's always on.
Yeah, it's just through Zoom. So as long as Zoom still exists, you should be able to find the
Yeah,
recording.
we convert the video to Vimeo so that it's always on. So you'll have that link in the email along with the slideware so you can access that. And I always recommend if you want to kind of like take a double click into this or there's a specific product, either join us for the next AWS workshop or join one of the more product specific workshops. And as you can see in the chat, there are so many resources, blogs, workspaces, GitHub repos, you name it. Lots of resources. So please feel free to take advantage of that. Databricks is not short on documentation, so there's
That's for
plenty to
sure.
go around. All right, I'm going to close the session out. Thank you everybody for hosting. Alex, certainly appreciate you kind of walking through all of the various sessions. And hope everybody has a happy Thanksgiving if you celebrate, and happy holidays. Thanks,
Sophia. Thanks everyone for attending.
Thank you, everyone.